I cannot hear you, but I'm fairly certain people can hear me. Nothing yet, but all I need to do is present, and if everybody can hear me.
Can you hear me now, Michael?
I can. Perfect.
Hey, thank you. Welcome, everyone. Microphone problems. And yeah, I'm sorry for that, everyone. Azure Innovators Hub, Freestyle Summer Jam session 2026. We have Michael with us. An attempt to have some high value speakers in a very smooth type of sessions, very low profile, but be aware the ideas could be quite extreme or could be very, very helpful for everyone. So thank you for joining. This session is going to be recorded, and I know that our audience is usually watching them recorded. So I don't know if anyone is still joining, but Michael, thank you again for being here with us. It's the first time I met you, so if you kindly can introduce yourself, that would be great.
Absolutely. And I am sharing the screen. Let me all introduce myself through the deck. There it is. All right, we are good to go. I'm just going to make this full screen over here. Pull it down. Thank you, everybody. Good evening, afternoon, morning, wherever you're beaming in from. My name is Michael Heath. I'll introduce myself in just a second. Titled this is Skill Buddy, which is a solution I developed within the Power Platform, which is kind of a little bit starting to be obsolete already. We'll talk about that a little later. So really, this is just a hands-on tour, really a demonstration overview of skills in the new Copilot Studio. When I say new, we really have not just put lipstick on it. We've really come up with a new architecture. So Microsoft's built out a new architecture. And for me, it's all centered around skills. And so that's really what we're going to get into today. Michael Heath, I've been in Power Platform, Microsoft for 15 years plus. And I always used to call myself an automation nerd. I authored a book called Enterprise Automation with Power Automate, years of teaching it, led teams inside Power Automate and automation. And it shifted over the past few years. And now I'm an AI nerd, and that's what I do. I'm a consultant, and I really enjoy working with a lot of different organizations. So over the past couple of years, I've been revamping my website, getautomating.com. It's a site just for me to really collect my ideas, but also share those with the community, which is why I'm here today. The community's helped me out so much. And now I'm shifting over and like, hey, people really want to see this technology. So I've really been pushing out more and more content in YouTube. Add me, subscribe. That's what really helps get the word out and helps individuals soak up this information, which is changing about every 2 hours, I feel like. I'm from Indianapolis, Indiana, in the United States. All we have is corn and basketball. Trust me, you do not want to, other than the basketball, you do not want to be here and check it out. So let's get started. So what I want to do here on the agenda, 4 things. Really, I want to talk about the difference between instructions and skills. There's some nuances there, and I think people really need to understand that. The second, what makes up a good skill, how to read and write those skills. Because I think, reading and writing a skill, it's going to be a expected skill for everyone to have. I define it later as the new citizen developer. That's truly what I believe. Excuse me. 3, watch Skill Buddy. Like this solution I created, I think it will be insightful at the very least, even though I've got a better idea, and that is to look at what the Copilot Studio CAT team has come up with, and I've got a challenge for you there. So, and let me just go ahead and start this timer here because that way our time won't get away from us. So where we're at today, right? We've got this thing called skills, right? And it's a part of the new agent experience. If I bring this over here, we're looking at Copilot Studio. This is an agent that I built, and we can see that skills are stuck in there. And so, but what are skills, right? they're nestled now within instructions, knowledge, tools, memory, all the things I just showed you there. And the biggest thing is we don't have the topics that we used to have, where we have to go bounce from node to node inside Copilot Studio. And it was almost like this everything was a conditional. We looked at keywords. Skills are solving in part for some of that. So it's really starting to give an agent these unique characteristics and traits that they can pull from on demand. Now, that is going to be created in a markdown file, and we'll show you what that looks like, and you'll see it firsthand inside Copilot Studio. It's a text document, right? Now, skills are not just a single file. We'll talk about that. They make up much more, but really it's to give the agent specific task information so it can carry out its job. Right now, you can in Copilot Studio, you can do this a couple different ways, right? You come over here, oops, there we are. And when we click on this plus icon, we can see we can upload it, or we can have our hand at creating it from scratch. So we've got a couple different ways to do that. We'll talk about how we get to a place where we can upload that. There's some shortcuts we can discuss as well. But really, this changes everything. If you're familiar with the way Copilot Studio used to work, topics were clunky. Lots of work goes into them, and then sharing those out, it's a little bit of a nightmare. So the idea of skills is really embodying democratization of AI, being able to share these, say, hey, you know what, like, we don't have to build a whole new agent for this. If my agent just needs to do a particular thing, like help me choose what coffee I'm going to have in the morning, I'm going to create a skill for that, and I'm going to share that with somebody else, so that their agent now has that particular skill. So today, distribution is per agent, so I do need to say that. And a skill really travels with the agent. In other words, if I have a skill, and by the way, this skill is something that, you go out there in Copilot, it can read a skill. Claude, it can read a skill, right? These things have the abilities to read these markdown files. So I can take that copy and plop that down just about anywhere I want to. And now that particular object agent, it can travel with it, right? So that's kind of just a little overview of skill. And like I mentioned earlier, these are all part of the new agent experience. So if we click on this reasoning loop here, I want to show you, a lot of people view this as like, oh, wow, Copilot Studio has this new user interface. And that's not just the case, right? Yes, it looks different, but the back-end orchestrator is different. So before, you'd have sort of this one-pass linear workflow, intent, plan, then you execute. Well, it's a little different now, right? It goes through a loop. It goes through a loop and starts to gather and reevaluate each time and observes what's happening until it gets to the goal where it says, okay, I've reached the outcome, what was asked. And this plays right into the hands of a skill, because what you're going to learn is skills are going to be pulled and ran on demand. So they're not like instructions that are ran every time. We're going to focus on this first row here. Yes, there are other things in the new Copilot Studio experience that are really, really powerful. We could spend a whole day looking at just these. So we're just going to talk about the difference, what makes up these bare bones. Instructions, again, they're loaded every turn. We're going to see this in real time. And the skills are padded sort of by your knowledge, right? Where are you pulling this data from? Is it from the web? Is it from specific knowledge sources? And then we do still have tools here where we're looking at connector actions, NPC servers, APIs, workflows, which is now new, really something to be excited about, because before, when we think about skills, right, skills have the ability to push towards deterministic, but they're still really in that gray area where you can ask a skill something, and sometimes you get a little bit of variance, a little bit of drift, right? That's where these tools come in, the workflows come in, where it's like, hey, I can't have any drift whatsoever. I need deterministic. And so that's really where these other parts come in. Let's take a look inside Copilot Studio just so we can drive home the points in the parts of the puzzle here. I mentioned before, we're not going to look at Microsoft IQ, but you do have the ability now. You have Fabric and Foundry and Work IQ. Just a month ago, I feel like it was only Fabric. So that's really great to see. We talked about skills here. We'll be digging into this more. I have a skill loaded into what I call Skill Buddy, which the primary purpose of Skill Buddy is to A, help me build a skill, but B, I want to share that skill out and democratize it. So it's got some workflows in here, and we'll look at those as well. And these workflows, again, give it a deterministic pathway to say, hey, if the user chooses to, you are going to do X, Y, and Z, and you'll do X, Y, and Z the same way every single time. Now, knowledge isn't a huge part of this, although I should say specific knowledge isn't. We do want it open to web data. And the reason being is because it's going to be able to help build skills when it doesn't necessarily have that information. So if I ask it, again, giving my example of choosing a cup of coffee, well, it doesn't have any frame of reference there unless I'm telling it, hey, these are the roast levels. These are the, espresso versus drip and all the, complexities and those types of things. It doesn't have all that. So I'm going to use the web for that. And I'm also using a SharePoint site as well. I'll talk about that a little bit later. But that's it. That makes up our agent right now. And like I said, skill's going to be doing a lot of the heavy lifting here. So let's come back over here and continue on here down the road. Okay. So I talked earlier about, the difference between instructions and skilled. So instructions, those are things that define the entire agent. This is the DNA of the agent. What is true every single time. Now, what's interesting here is you see the instructions, and let's say this is not incorporating skills. Okay, this is the amount of effort I need to put in my instructions because I have to tell the agent what to do. And thus, if I'm not using skills, I need to make sure that all of this is in there. So we can see that, when we're looking at these instructions, in the life cycle of getting the response, getting the desired outcome that we need, it's about 11,000 tokens. This is all made up, but let's use that as our reference point. Right. And so now, again, every time we run a cycle, a back and forth, getting us closer to the outcome, we have to run these instructions. But if we push some skills in here, right, we are, again, remember, instructions are always on. Every time we run that, we've got to surface those up. So if we're using skill, though, depending on what's being asked for, it's going to load that skill at the point of time. And notice what happened to our instructions. We've been able to shrink those and say, hey, this is who you are. And when you get to the point to where something someone is going to ask for a specific thing, like, oh, hey, I need a plan to help me study for AI 103. Oh, well, we know we don't have to go through all the characters in a long set of instructions. We can just call upon that skill. We're going to execute that skill, and that's what's going to help us get to the outcome desired. Now, I'm not using all these skills in Skill Buddy. It's quite a simple agent with one skill, and it has some scripts along with it, which we'll talk about. This is just to give you an example that I could load up multiple skills, and they're not going to be called upon every single time. It does carry the metadata with it, but it doesn't execute on it. So this is where skills start to be really powerful. I do see there's a huge shift from organizations that have, just a couple years ago or even 6 months ago, we're still trying to figure out, what is the value of AI? And I think everybody now knows there's lots of value in it. They've experimented with it, but now they're starting to get to that point where they're like, okay, now we really have to understand the cost versus value. And when we think about skills and we think about optimization of our agent, skills is at the center. So just keep that in mind. So a skill is a procedure that the agent picks up on when the task calls for it, right? So we give it a name, right? In Copilot Studio, It's for right now, it's skill.md. When you go to upload this inside of Copilot Studio, that is what it's going to be looking for. It's going to be looking for that skill MD file, okay? So the description is when to reach for it. So remember, and I want to say remember like it's in the past, but I think we all are guilty of this, and we are very accustomed to looking at a description and thinking it's an aesthetic, meaning we don't have to do it. It's nice to have, especially in documentation. We're terrible at this. Give it a title, it's fine, works. When we talk about the description, right, it's really important to get descriptive in this. Now, we don't have to go overboard, right? We want to be fairly accurate and to the point, because again, we're talking about tokens, but we want to be able to really describe what this thing does, because that is going to act as the trigger when it's run on demand to have it execute on the proper skill. So, and then we talked about instructions as well, how to do the work. Now, here's the deal, right? Now, I created Skill Buddy here to help me build out skills. Most any AI engine model, Copilot chat, Copilot Studio chat is going to be able to help you create a skill. So Skill Buddy as a method to create a skill, not really necessary, right? You can go out to any platform you want and say, hey, you know what? I want to do this thing. Help me create a skill. And it will create a skill and you can import it. What I've found is with Copilot Studio, if you're not doing it natively, then you might have some front matter issues, which is some optional data there. It has to be in the right format though. So time to time, I see some issues there where I'm not getting the right front matter, but I would also encourage you at first, build these skills out yourself, right? Start to dig into them and, try to pull them apart, see what works, what doesn't work. And it's an iterative process. And that's really important, right? So again, this is just to drive home. Instructions are an every time thing, but the skill is only sometimes. It's procedural, right? So keep that in mind as you build these things out. Now, again, metadata always, right? We have idea of here. Here's a good example of the tokens. And I think we're going to push into the space where we're really able to see this granularity. Right now, you can go into Copilot Studio and PPAC, Power Platform Admin Center, billing, and look at particular runs. It's not in real time, right? But it's something you can do. But take a look at this, like, turn one. I've got my exam in 6 weeks. I've not started. Notice that when we say that, it automatically will recognize that from our skill, exam prep, learning plan builder, and it pulls that into the fold and it spins some tokens, right around 3,000 tokens. We have 6 skills registered in this thing, but it's only going to pull in that one. Now, then we ask it, we say, okay, hey, turn that into a skill I can install. And we've burned a little less, but again, we're only pulling on that one skill. Now, look at this other one here where it is, what is our PTO policy? Well, guess what? That's just knowledge. So again, this is where the description of the skill comes into play, and we can start to see how the different pieces, knowledge working with skills in the instructions, letting it know, informing it exactly of how we want to get this outcome to the end user. So no skill fires in this because it's knowledge. So it's able to, again, that's the beauty of the new architecture where it's able to go through, evaluate, observe as it moves through the loop. So really important there as well. So the other thing we got to talk about here is how a skill is not a package, or excuse me, a skill is a package. It's not a file. And, I could easily run this particular one. We'll hop over to Skill Buddy again and try to dig in a little bit And we won't run it yet. I've got time later on in the demo to run this to kind of work through it just to see what's going on. But we have our instructions here, and these instructions probably could be trimmed up a little bit. They're pretty heavy, but it's an iterative process. So I'll go through even this morning against my better judgment, knowing I had to showcase some of this, say, hey, how can we squeeze these in a little bit more? And can we optimize the skill a little bit? And one thing I'll tell you, just word to the wise, if you're building out a skill and an agent and you have multiple nodes like this, where it's got a workflow in it, it's got some knowledge, do as little as possible in terms of developing the skill and bringing in extra objects such as workflows and knowledge. Do as little as you can first. And the reason I say that is when we're able to isolate something, we're able to understand exactly how long things are taking and what tokens and credits are being used. So if I have other things like tools in here, for instance, this particular tool has to convert stuff to binary base 64, right? It has to make that conversion. And that takes some time. So if I look at the average runtime of this with the workflow, it's about 6.5 minutes. If I take out the workflow, we're down to 1.5 minutes, 2 minutes. So you could see, like, just I wanted to pull that out so you understand exactly what's going on there. So if we look at the skill here, though, this is what I talked about. We could give it a flat skill MD file, and this is what that looks like. We could also give it some other things. One, which you see here, scripts. The others are references, and we'll talk about those a little bit. So the more and more you add to this to really evaluate what's going on here, the faster and more a specific and accurate response you're going to get. So let's dig into what the flat file is and then what these other ones are real quick here. So we talked about the skill MD file. That is the basic one. That carries your instructions for the skill, not the instructions for the agent. That was something different we looked at. And as you can see here, we have our skill name. It's always going to be the skill MD file, though. We've got our description here as well, and our optional front matter. And then we have our instructions. And again, what I mentioned to you here is if you're struggling to create these things, use AI to help you with that. Beyond just the flat skill MD file, markdown file, we have a few other things, right? So if we take a look at this thing called references, right? This is when we have a skill that's growing fairly large. In other words, if we have a main skill, but think of it kind of like what we had in child agents. When we have a skill that's growing larger and larger, and we think about multiple pathways and offshoots and specifics that we're asking for, then we maybe need to add in some helpers. And that's exactly what the references are doing here. They're helping with specific parts of this, where the agent takes some paths that it may need. So again, if I'm asking for some, inside this, I want you to give me the full quarterly review, and I need you to give me the executive briefing. Those are two different things. And if we start to push in all that stuff into one MD file, one, it's going to cost us in terms of resources, but two, it's going to start to bring in some confusion. So when we think about references, those are also little helpers there to guide it down the right path, okay? Then we have what's called a script here. Now, depending on your platform, we may ask inside Copilot Studio, we may have an ask to do certain things. So, things that are mechanical, where we want an identical outcome every single time. This is where it gets to be a little more deterministic in terms of output. So my example here, you got to write it in a docx, and it needs to be this way, or PowerPoint needs to be this way, Excel, right, so on. Validation, right, has to match this particular schema, needs to be in this particular package. Those are real outcomes, real mechanical outcomes. And so what we can do is provide it with the script to help it. Now, And what that really does is helps it understand without having to reference that over and over and over again and look at, okay, how do we need it? It said we had to do this, but how do we really do that? How do we build a Word doc? Okay, fine. Now we have a schema for that. We've packaged it with it. So it already knows, this is it. And this is the way I'm going to do it every time, rather than trying to build that from scratch. Okay, we have a few more things in here. This is really an example of, right? And that's what ships with it, right? Instead of trying to describe a template for a PowerPoint, which is a nightmare, right? It's going to be very costly inside the Markdown file. We're going to provide an asset with it to show it, hey, these are the colors that we're incorporating in it, and here's the template that I want to use. Now, over in my example of Skill Buddy, I really didn't need to have a script in here, a validation script. That's all that this is doing. I could go with a flat file here, and it is an iterative process. So you're going to find certain things to where if I add this in here, I particularly may be extending that time to outcome. So it is still something that you should build in an iterative process. But here's what I have in here. It's a zip file I've dropped in, has my skills in here, has my scripts in here, and off to the races. So now we wanted, this kind of piggybacks off of what I was talking about here in an iterative process. What we're looking for is really balanced. And the reason I say that is because, if we're very tight in what we're giving the agent or the skill, if we're very tight in what we're doing, like towards that almost deterministic, it's not going to allow for a lot of flexibility, right? It's going to be so tight that it breaks under pressure, breaks under deviation. Now, what you can do here to help with this, Copilot Studio does have what's called evaluations. And these are going to help. You can either come up with your own questions. I don't have any in this one, or you can build from scratch and preload them up in there. So you have a number of different ways to approach this. But my point is here, we want, where we really want to be is balanced. We don't want to be too open either. So if we're not descriptive enough, we're offering kind of free reign, go do what you want, right? And that's not something what we want either. What we really want is that balanced approach, right? So we're able to give it the proper skills, give it enough of the scripts and references that it needs to get us to where we desire, but also that flexibility is AI after all, we want it to approach this with a little bit of that helping hand. So if we think about that particular approach, I want to just kind of, these are things that I live by when I build out my own skills. When I have an agent build out my own skills, I ask AI to build my own skills. These are all principles that I put in there that I start with, and I sometimes push and pull those depending on what I think. Now, this routing signal, this is arbitrary. Wouldn't it be nice if you gather that, like put it into a score, which you could do. You could build a skill that does this actually. But this is just, these are arbitrary numbers, which is, notice here in the description alone. So we have the right length of characters here, and that's fine, right? We get a score, we've got the right length, and fair enough. Now, this one's pretty vague though, right? And that when we look at the continuum on the last one, we really want to kind of say, okay, well, what are we doing here? Is it just like, do we have a good idea, or is it just kind of floating around? And this one's kind of just like doesn't have anything, right? So let's add a few more. It's a little bit shy, right? Not so eager. And we've added in some other ideas here. We've added in some other parameters, which, the description, we've trimmed it up so much. This is a really good example of the iterative process. It's too long, right? So we're going back down, and that one's kind of fallen off. Although we've started speaking in third person, right? Not a command. We've eliminated any kind of filler words. We don't want to at the end say, oh, and by the way, one more thing, kind of like the old Steve Jobs Apple developer conference, right? We don't want that either, because that adds a lot of confusion, and it's kind of out of the order of operations anyway, right? So when we think about that, it costs a lot for us. But we do have the keywords in the opening clause, all the way to, you can imagine, when we're like, this is where we want to be, right? We've balanced it out. We've got some good keywords in there. We've got names the trigger that hey, when do we use this thing? And this tends to be a real good working formula, at least in starting. And what you'll notice is, as you build these things out, it's not a one size fits all. So when you start to introduce other parts of the process, workflows, knowledge, things like that, you may find yourself going back here and saying, okay, this worked for the last one, but maybe I need to tweak this a little bit for the following. So really important there. And I think I covered this a while ago, but don't make them too big, right? This is where the references and other parts of the markdown file, markdown package come into play. We don't want one big skill that does everything. Start to split these off into various skills or even subsets with references. Make sure that we're very descriptive in what we do, not overbearing, but we want to make sure we name the artifact, triggers, and what the scenario is. And then lastly, going through the bottom row here, we want references, right? But we don't want them to be obscure. What I like to do is call out those files specifically by name. I did this when instruction mattered a lot. A lot of times you could use the / or @ symbol. When you can correctly tag an artifact, we want to use that in everything that we do. And I'm going to bring over, there we go. Let me bring this over here. Over to my agent. All right. Avoid fact dumping, right? That's what knowledge is for, and over explaining. All right. So I'm going to go ahead and start this. We're going to let this skill buddy. And so, just in summary, and we'll start this off now because it takes about 7 minutes for it to run. And while we're doing that, we'll go through the rest of the presentation. So at the end, here in about 10 minutes, we have built out a skill. And we can kind of see what this does, and a few other artifacts that I built here. So the whole idea around this was I wanted to democratize skill building. So we've got the instructions here, we've got the skill, and the nice thing is, right, I don't even have this published. We can go over to preview and say, I need to skill to, let's see, help me choose an outfit today. All right, so here it is. We start working through it. And what's really cool about this is that we can turn off commenting, or we can go with end user right? We can go with end user preview, or we can just have it open. I love having it open like this because we're able to see exactly what's happening right here. We're looking at the skills catalog, by the way. Skills catalog, what is it? Well, it is a SharePoint site. A SharePoint list, if you will. And in it, we have our MD files. It's checking to see, does that exist? As we go through here, it says, great news, nothing in the catalog. Perfect. And I get two options, right? And I thought, well, this is usually the Microsoft way. You can describe, design it, or it can guide you through step by step. And for the longest time, I did guided authoring just because I could kind of understand the process there. And that's another reason why I built this, to help me get better at skills. Today, I'm just going to do describe design. I'm going to be lazy about it, especially given the time. So it says, perfect. Give me a short description of the skill. Does it, ask about the weather, full outfit, all those things, right? I can give it a phrase in description. I'm not going to. I'm going to say, all those sound great. And spell it, even though AI is pretty good when you make those spelling mistakes. So it says, I love it. I'm going to generate it. And now it's going through, and here it is. Just like that, fairly quickly, it's got our first draft. And this was what I was talking about. Like, you can go out there to Claude, Copilot, and do this same thing. This is not where the power exists, although I do like the guided approach. You can tell those other platforms to do the same thing. The real power comes into the workflow here. And again, like we've got a problem. So it's going to create something for me here, but it's just going to be a file that it drops with me. And I'll have to go download that file, save it somewhere. But then, how does this get shared with anybody else? So we got the Python script doing its work right now. It's validating it, making sure everything's okay. Little helper script, and I want it to validate the same way every time. So this is good. And it's got the summary there. It's working through it. Would you like to tweak anything? Once you give the green light, I'll save it to your OneDrive. Now, this is an interesting response here because typically, and I didn't say my prayers to the demo gods. Typically, what I would look for there is it's going to give me two options. Would you want to save this to your OneDrive? Do you want to save it to your OneDrive? And do you want to share it out to the skill catalog? So I'm just going to say it looks good. And we'll see where we land here. And if not, it's not all broken here. Look at this. So right here, notice here it is. So I would like to see this, maybe specifically rewrite that skill or the instructions. And why would you ask them that? Just move through it. And the one we want here is save to my OneDrive and share on the skill catalog. So why that's working, doing its thing, it's going to start processing this. Now, like I said, this is a little bit of a process here, right? We're going to come back to that. It's looking at knowledge, by the way. It's going to ask me one more question. And interesting enough, it's supposed to be checking the skill catalog. It's supposed to be checking to see if there is what categories we should map to. And it says it can't do that right now. I think I probably broke the connection this morning. But I'm just going to go ahead and say, hey, this one belongs to lifestyle. So when that's working, we're going to come back over here. We're in agent ops right now. We don't need to be in agent ops. But we're going to look at the workflow that's attached to Skill Buddy. Again, I created this. This should look really familiar. If you've used Power Automate before, then you know that this is essentially Power Automate. But basically what that workflow calls for is it has a number of different inputs. If we look back at Copilot Studio here as we're working, I'll just duplicate this one so we don't mess anything up there. All right, go back, good. And we'll go back to our agent. And by the way, I'm in copilotstudio.preview, so you can see the full new experience, and you get your little Copilot chat bubble, Copilot Studio chat bubble. Really important there as well, so you can see this exactly what I'm seeing. So what I was going to show you here is over in Skill Buddy. You notice that in here, it's not opening up to the workflow, but we do have our inputs here. And what's interesting enough is this is where I can get non-deterministic here. I can use AI to fill in all these. These map to our workflows right here. When an agent calls a flow, get that data, we're passing it back through the agent. We're going to create the personal file. We have to convert it. This is really what takes the longest time. Now, I could push this to a variable, so it's not having to do this every time. Now, that was the 1 minute signal I hear, and that's fine. We're going through. We're now creating it. And notice I call it upon, and again, it's doing the same thing again through an expression. We could pipe a variable in there. But that's essentially what it's doing. And it's now going to save that off to, not only does it save it off to my personal drive, which is saving in OneDrive, it's going in here and it's going to save that as well. So let's pop back over to, here we are. While we've got 25 seconds left, we're just going to pause that now so we don't get the annoying buzzer. And we'll see it in just a minute. I guarantee it's going to be up here soon. Why did I do this? Well, I did it because I think, again, skills are going to be the future. That is what, when we talk about a citizen developer, it's no longer been like, I built out this big solution. No, I'm going to build out a skill, and that's going to be a big part of it. So that's really why I looked at this to say, hey, we're going to build this out. I need something that I can truly share. And so the cool part is I also, now that everything's hooked up to that, I went ahead and created an app for it. And I hooked it up to the SharePoint list. And now I'm able to have an app that I share out. And by the way, all this is on GitHub. if you go out to getautomating.com, you can go to the repo, you can download all this. It's not perfect. This is just like really quick, but you're able to, add things to your skill. Hopefully we get a green there. This downloads it to my personal drive, and then I can pull that. I can also go in and rate this. And there's a separate list in there that I didn't show you that it holds all the rating information from the org, so other people can rate it. And I share this with you, and then 1 week later, we got something different. Something else showed up, and that was the CAT agent skills here. So this is public. This is done by our Copilot Studio CAT team. Fantastic resource. You've got a repository of all these different skills here. You can download those. You can use them for Scout, Copilot Cowork, Copilot Studio. You can do that, and you can contribute your skill, contribute a skill yourself, which is what I would highly challenge you to do. You can upload the MD file or the zip. Like I said, you don't have to run it from scratch. Download one of these other ones and start working with that, or go through Copilot and make it your own. There's lots of shortcuts there. Lots of references here. I'm going to sit here for just a second, and then we'll pop over to our agent. I know we're very close on time. So one thing, you can view the skills overview here, the CAT agent skill catalog that you just saw. Migration. So a lot of you are thinking, well, great, now I've got classic agents and I really want to take advantage of skills. That's fine. It's got a migration plugin. I also have a video out there, a little bit of a shortcut. And I think this is going to be a shortcut for end users. But if you're looking at enterprise agents, you probably want to move towards the migration platform. And then let's go back over here and Copilot Studio and wrap things up somewhere in here. Here we are. All right, all good to go. Yes, and looks like it's doing a final publish. I should have clicked on that. It'll be working in the background, but the idea here is that once it's done, it has the skill. It's now saved that to my OneDrive, and it will save it here to our skills catalog as well. So we could essentially download this right now or go to the catalog and view it from there. Just to wrap things up there, again, this is my challenge for you, right? Write one skill this week and submit it. Go out to the CAT catalog, the agent skill catalog right here, and write a skill, right? I guarantee you will learn something from it. You are going to have to use GitHub Copilot or Claude to deploy the CLI. It's all GitHub, right? And you'll learn something there as well. So again, a few videos on how to do this are out there. And I think those will be something that will be beneficial for you as well. I know we're at time here. I think I believe we're going into a Q&A part of this, or any sort of follow up. But that is it for today's presentation. We'll kind of let the other thing here mellow out while it's running the workflow. Really, this is that base. It's converting it, right? It's got to go. We got base 64. And so on. So that's really the workflow, the heavy lifting that it has to do. Otherwise, the skill was created long ago. Now it's just being shared out. And with that, that is all I have.
Excellent. Thank you so much, Michael. That was really amazing. And we have a question. How much effort did it take on development? So I'm guessing the question is about, how much time did it get you to prepare this and everything?
Yeah, it's getting to be less and less every day, right? Now, I'll take a little bit of a biased approach and say I've been working with Power Automate for a long time. So, I could see that a lot of people get stuck when they try to create a markdown file and save it off to SharePoint. It's not shared in the correct format. So the key there was, if we look at the personal, I've got an expression here that is being run. And a lot of times that's a sticking point. But you can see here, what is it? 1, 2, 3, 4, 5, 6 nodes for the workflow. The actual, this part here, I mean, that's all AI anyway, right? I had AI write the instructions. I had AI write the skill to author the skill. And you know what? There's even a skill out there now. Let's see, I think Margot had one out there that helped, a skill authoring coach. So there you go, right? So you put that in there. And really, you know, you're not talking about a whole lot of time. I'll tell you what took the most time is the Power App, right? Because I don't think we've got that to a place there. You can describe it and design it, but you know, we kind of, it's a little clunky still. So that there was the majority of the time. Everything else, saving it to OneDrive, saving it to SharePoint, you know, that was, you know, a few hours, if that. Right. The Power App took me a few days just because there's a lot of manual work there just to get it right. And not only that, but you also have a UX UI that you have to build out, right? Something that somebody's going to interface with takes a little more time. But I think that a lot of that stuff's moving to CLI. There, we were actually looking at it right here. A lot of that stuff's moving to CLI where it's just like I can build out a workflow and just tell it, especially like GitHub Copilot. So yeah, that's yeah, I would say a few days, right? Given the Power App as well. And I don't see our skill. Maybe this is it, right? But oh, there it is. There it is. Anyway, yeah, a few days.
Perfect. Thank you so much for answering the question. One more, and you're free to go. Would you say that the whole Power Apps ecosystem have been has evolved before the AI revolution, or it came hand by hand with the AI stuff and everything?
Yeah, so this is what I think in terms of where we're at, and I'll speak in terms of the Power Platform ecosystem because you know that's something that's very near and dear to me. It used to be, you know, when it first came out, you know, being a SME of Power Apps, application design, development, automation, Power Automate, PVA, if you can remember that, Power Virtual Agents, all those components when AI was just kind of starting to sprinkle in. You could be a SME and you could do okay. Now it's like, wow, like I can be a SME of this thing and that's about it. So here's what I think. I think that a lot of this, you know, Power Apps, as you mentioned it specifically, was curated and designed and conceptualized before the AI revolution. I truly believe that at some point in the near future, we're already seeing it in bits and pieces of this, where you see, you know, workflows coming into these, where you have the merging of deterministic and non-deterministic. I think very soon, all this is going to live under what we know as Copilot Studio. And you heard it even last year, Charles at the Power Platform Conference said low code is dead. And he didn't mean like there's not going to be low code citizen developers out there. Low code as we know it is dead. So I truly think that Copilot Studio is going to be the thing. And when I'm interfacing with Copilot Studio, if I wanted something that had a user interface, I would say, hey, and also build me out an interface. And then we're going to bring Power Apps in, right? But it's going to map it out for you beforehand. So I think that like we're in this interesting state of limbo because we do have a lot of architecture that didn't necessarily take advantage of AI. And what we're starting to see is a shift into those that do. And I also think, you know, along the lines of Copilot Studio being this interface kind of hub, if you will, to kind of, you know, push out like you sort of delegate certain tasks to Power Apps or Power Automate, agent flows, or workflows. I also think that CLI is going to start creeping in. It's actually something that I've ran from for a long time. I hate CLI. And over the past year, I've started to jump in it more and more. I worked myself through the migration tool, which is all CLI and things like that, right? And I do think that even CLI is getting to be where it's starting to wedge towards low code and the utilization of AI. So I think we're just getting started, but I do see Microsoft going back and starting to reevaluate if their platforms are taking full advantage of AI and how it's integrated into the existing ecoverse, such as Copilot Studio, Power Automate, those sorts of things.
Amazing. Yeah, yeah. I just started using again Power Automate. I was a little bit away, but I was amazed by how easy it has been. And now with the Copilot Studio innovation, with the new user interface that you got everything there, the workflows. But I keep the CLI comment from you, Michael. I think it's something really important, and developers, citizens developers, everyone should start looking into it. I believe it's quite important.
100%.
Thank you. Thank you so much for being with us. I'm really grateful that you had the time to present live. I hope we will see you in another event of ours in Azure Innovators Hub. Have a great one and have a great summer.
Thanks for having me. Appreciate it, everyone. Take care.
Bye bye. Well, that was Michael. Quite interesting session. And how many new things are we going to explore, learn, discover, and experiment with? Peter the Lender is coming with us, one of our top tier guests and a wonderful speaker. He has a lot of experience in the Microsoft ecosystem. He's going to present today in Freestyle Summer Jam 2026. Let's get a break and we will be back really, really soon with Peter. Allow me to play a video or something, grab a drink, uh, cold or hot, whatever you prefer, and we will be right back. Thank you, everyone. So yeah, we're still waiting for Peter to join. Um, Remember to subscribe to our YouTube channel, Azure Innovators Hub. It's under the handle Kpasadis. I will add the link in our in the stream. And thank you everyone for joining, whether you are watching this live or the recorded session. In total, we're going to have 5 sessions today. We have already said goodbye to Michael, and we're going to continue with Peter the Tender. Allow me to validate the the name of the session. So Peter is going to present spec-driven development concepts for Azure scenario deployments. So I really like this event. It was created with the the summer vibe in mind. Being really cool, really relaxed, nothing too serious, and allow the speakers to have their own ideas come into this either live or pre-recorded session. Doesn't matter. Our next speaker is live and it's coming from any moment now. So yeah, we will be right back with you very, very soon. Azure Innovators Hub Freestyle Summer Jam 2026. We're back. This event was created out of the idea of let's create something that speakers can present their own ideas, their own experiments in a very cool, smooth way, no strings attached. So whatever comes is welcome. And we have Peter with us. Peter has been supporting our channel and our community from the very beginning. So I'm really grateful that and happy that we have him with us today. Let me bring him on stage. So welcome, Peter, once more. Thank you so much for being with us, my friend. How are you?
Yeah, doing good. Doing good. What about you?
We're in the hot days of summer, and we're trying to get into the beaches any way possible. Tell
Yeah.
you the truth. Yeah.
Yeah, I heard
So
it's getting a
yeah,
bit warm in Europe, right?
yes,
I'm
and
gonna try and
other
switch my cameras, by the way.
yeah other countries were much hotter than Greece this year, which is strange, but all in all, everyone is hot.
Yeah, well,
So
the
yeah,
Seattle area has been okay, I would say,
okay,
because it's typically like, oh, it's gonna be summer, and I mean, in the end, everyone always complains about like weather in Seattle is awful, but during summer, it's actually quite okay.
really,
So
okay.
yeah,
So
like
you live there, right? You live there in
yeah,
Seattle. Is your
close
base
to
there?
5 years now. Yeah.
Okay.
Let me try and share my screen. Had some challenges with getting into the platform, so I want to make sure that
Yeah, I saw
everything
your
works.
messages. But if you wanted to overcome these, that's great.
Do
Yeah,
you
I can
see
see your
my
screen.
screen?
Yeah, yeah,
Awesome.
yeah.
Cool. Then I
I'll let
guess I
you
guess we're ready.
introduce yourself, yes, and your session. Thank you, Peter Tedder,
Good.
everyone. Thank you so
Well, so
much.
first, I would say thanks for having me. Always fun to like share a little bit of knowledge, especially when you get invited to present on a topic that is a bit, I would say, floating into like the present, the future, but also blurring the lines between developers and cloud admins. So I hope I can share a bit of how I'm using it, although I'm not really into Azure that much anymore, but still using the same concept. So first of all, thanks for inviting me. Second, I would say thanks everyone for joining. This is live. I know that we could record this, but I always like to talk through this as live as possible. So I hope everything's going to work out fine. So I'm Peter Detender, originally from Belgium, but as you could hear, living in Seattle area, close to Redmond, Microsoft campus, where I joined Microsoft out of Belgium a bit more than 7 years ago as a Microsoft technical trainer, at least full time, was already working as a vendor for them for multiple years, together with other customers, providing Azure workshops across the globe. And then when they started internal trainer team, I decided to join them as a full-time trainer. And then recently, like literally beginning this year, shifted from the trainer team into content development team, where it's mainly still supporting like learners, because everything we create is learn, but also instructor-led training videos. So anything that looks, feels like material that could help basically any learner across the globe is a little bit of our responsibility. And then my focus domain is DevOps and stretching a little bit to AI and development. And that's where a little bit of that blurry world, I would say, we're in, is showing up more and more thanks to AI, obviously. So I got a session that I described in the session topic like spec-driven development, but then not developing as such, but it's targeting Azure infrastructure, which means Azure cloud admins. Big reason I'm doing this is again because I think everyone should sort of become developers. And it's interesting because if you think about my own background, even before I did like Azure workshops. I started 30 years ago in physical data centers, literally building the power, the cabling, the cooling, and then gradually moved up. And developing was never on my radar. I only picked up developing like about 4 years ago now. And if you look at the details of technology, it's around the same time that GitHub Copilot went live. So I used it as my help instrument to pick up .NET. And I hope I can share a little bit of that development mindset without scaring like cloud admins away, because you don't really have to be a developer, but I think we can pick up a lot of that development excitement. And that's mainly what I'm going to try and cover in this session. So that's mainly it. I actually asked Copilot in PowerPoint to help me building this deck. And then obviously human in the loop, which you hear me saying multiple times, to make sure that we're not just trusting AI, but just using it and helping us as an assistant. So this is where I asked, like, can you provide a description how this topic could work for non-developers? So the main content is literally designed for mixed teams. Now, I'm a DevOps guy, partly because I own the DevOps content within the role, but previously working in Azure for me meant always deploying something using pipelines. So I always had that mixed audience, you could say, in most of my workshops, where it's targeting application developers, cloud admins, and then maybe site reliability engineers, platform engineers. Like, you know, this group of DevOps engineers is becoming bigger and bigger. Now, the shared challenge we have is basically the same. As a business, you ask a bunch of developers to start writing code. The ultimate goal is moving fast enough to what we call in DevOps, deliver value to the business. But then at the same time, we need to meet reliability, security, operational requirements. Where then at the end, you should be able to decide when to use vibe coding. And yes, I'll talk about vibe coding a little bit, because that's where for, I think, a lot of cloud admins and overall anyone using AI, vibe coding is really that, I would say, in my opinion, one of the coolest aspects of AI. It's not that I trust it for the 100%. It's not that I love it for everything. But at the same time, I think there are certain capabilities, certain tasks within AI technology today that just make our life as cloud admins so much easier. And then from there, I'm going to zoom in on GitHub Spec-It, which is one of those spec-driven development platforms that you could use. No surprise why I'm picking GitHub Spec-It, because it's part of GitHub Copilot within our Microsoft platform. I got like some sort of an official agenda, but not going to read out all the bullet points. But in short, it's about why should we absorb that spec-driven development concept. Talking a little bit about vibe coding, maybe bringing in a demo, although I want to spend most of the time showing you what the actual GitHub Spec-It can do. And most important, try to keep that mixed team experience in the back of your mind, where you could go like, well, I'm not a developer, but I'm a cloud admin. But then maybe you're 100% cloud admin, DevOps engineer, platform engineer, and you need to support your developers. And then zooming in on one specific scenario, that I'll try to use is how to map the concept of spec-driven development into building a more complete Azure infrastructure as code scenario. I'll start with vibe coding. Again, 4 years ago, I sort of picked up .NET. Why .NET? Because it's our Microsoft framework for developing. And out of my Azure workshops, I was always talking about how to run workloads on Azure. And I sort of lacked sample applications. So at some point, although my workshops, I guess, based on customer feedback, right, were always successful, I always wanted to show like a retail app if I was talking to a retail customer, showing a finance-related app if I was talking to a finance customer. But I always liked that development skill. And then about 4 years ago, in the early bits of GitHub Copilot, I finally had access to a platform, a tooling that allowed me to ask a question, can you help me building this kind of application? And at that time, feels like super outdated now, but it would just provide me like the commands, how to spin up like a hello world like .NET application. And then from there, going back and forth, running prompts. The strength to me feels like it's perfect for exploring. Like in my case, new developer or new to development and exploring something. But in the end, it's still writing code. So that's where we could lean a little bit into vibe coding for cloud admins. Writing bicep, flipping over bicep to Terraform, maybe you still have older Azure templates, or maybe you find them in Azure Quick Start templates, and you're just going to try and transform them to the latest and greatest. Or maybe you're struggling with, I don't know, deploying a Docker file, creating Kubernetes YAML files. Or another DevOps example. My background is Azure DevOps and TFS from like 15 years ago. And then obviously integrating with GitHub, where now we can use vibe coding to transform our code from one platform to the other. And again, keeping that mixed team approach in mind, where I'm trying to share just some examples how a non-developer could start using that vibe coding concept. And then obviously, I'm pretty sure a lot of you are already doing this, where nowadays with like GitHub Copilot agents or Cloud Code or any of the other platforms, it's becoming more and more powerful, where it's not just about writing code, but then also automating tasks and just helping you start to finish. Now, one of the risks at the same time with vibe coding is that it's probably not production ready. It's probably not following any of your maybe business guidelines or compliancy regulations or anything like that. I'm not going to say that you cannot create anything like production ready with vibe coding, but at the same time, it feels like I got this idea as a non-developer. I'm going to open up my AI environment. I'm going to run some prompts like help me building this kind of application. And in the end, sure, it does a good thing and it starts compiling. I actually created a video on this a couple of months ago as part of the Microsoft role, where I did a session on vibe coding a Python shooter game from like the arcade in the 80s. And I was literally mind blown how easy it actually is, where I provided a description, like I want you to build me Python code-based like shooter game, where it's basically just pressing the space bar. Like that's the games we played in the 80s, right on our, I don't know, 286 computers or something. And that was mind blown for like an 8-year-old kid at that time. We're now 50 years later, you could basically build the same thing by just running a prompt, waiting 5 minutes, and you got a full live game available. But again, is that like, oh, now I'm going to turn into the next, I don't know, Minecraft game using vibe coding? Most probably not. So that's one of these shortcomings. But at the same time, I would say there's nothing wrong with using vibe coding as a starting point. From here, the next part is spec-driven development. Now, spec-driven development is, I would say, technically nothing really new. Now, what we're doing is making intent explicit. What that means is we're going to spend more time on thinking about the goal, thinking about what do we need to have live in X amount of time, and spending more time on the brainstorming, the definition, the guidelines, bringing in all the requirements, the specs, right, as we should call it. And then from there, moving from an intent, this is what we want to build, or this is what we want to have live, moving from spec to plan. From there, you're going to move from plan to execution, and then eventually validation. Again, if you're a developer, this sounds pretty logic. Although with vibe coding, most folks, I guess, are so enthusiastic about like, oh, I'm going to run a prompt and it's going to build me something. And then I'm going to have that back and forth conversation. And eventually I build an app that's okay. And again, it doesn't need to be an app, because you could, I mean, using Azure Infra as an example, I could open up my VS Code and using some sort of vibe coding concept to build me a bicep template. I actually think I'm going to do that for the ones who are still pretty new to Copilot. So I'm going to open a new session here. And bring it down here. So this is my VS Code. I'm going to open up my chat. And as you can see, it's basically my tool in my day-to-day job for pretty much anything that I'm working on these days. I'm using agent mode, which means that it's sort of using its own internal spec-driven development, which means it's going to use the large language model. I could pick any of them. I like that auto approach, where it's basically helping. I'll make it a little bit bigger. It's basically helping GitHub Copilot in deciding for this kind of task, like based on the prompt, what kind of language model should I suggest? And it's not always picking the most expensive one. Where now here I could go, help me writing a bicep template, which allows me to deploy, and so on and so on. Now, this is way too long. Now, I know it's natural language, and 4 years ago with the start of AI and natural language, generative AI, it was always about try to write as complete sentences as possible. But you don't have to, right? Because in the end, it's all getting translated to tokens. And if you're a little bit into AI, you know that tokens is where basically the cost comes from. So we could do write a bicep file to deploy Azure AI Foundry with Cosmos DB. And then sure, you can be a lot more specific, right? But for now, you would write this bicep file. And then depending on your setup, you can see here, it's trying to activate MCP extensions. Now, what is MCP? It's yet another component in this AI topology we're working in these days, where it allows you to sort of run API calls to a backend, where in this case, it's going to recognize you're asking something about bicep, so it knows that it's Azure related. I'm asking something about bicep, so it's going to try, as you can see here, loading all the different MCP server connections that I already have. The big benefit is that it's going to provide me like the latest, greatest information. It's connecting to our Microsoft Learn platform for docs and training content. It's going to connect to the bicep specific MCP server to bring me that latest and greatest bicep syntax with the latest APIs and whatnot. So this is going to run for a couple of minutes typically, and it's going to add a whole bunch of stuff in there. Now, if I look into the reasoning here a little bit, I'll zoom in and freeze it a little bit. It's probably doing a good job. It's going to add the storage account. It's going to add key vault. Okay, cool. That means it's taking in security into consideration. But what if we're not using key vault? What if we're using third-party tool? I mean, if you're not using any secret management, then please use key vault, right? Application insights, same thing. Like there's so many assumptions you could say that it's going to bring in based on the fact that I just asked for bicep, that it's Azure targeting, and that it's using Foundry. And then I explicitly asked for Cosmos database. And then it's also following some of the best practices, deploying a hub and project. And eventually, again, in just a couple of seconds, if I allow this session, sure, it's going to create me my bicep. Is this vibe coding? Well, I think it is. Why? Because I didn't really think a lot about what I need. I just went out running a prompt. And obviously, you could do the same for this Python game, .NET, whatever application you're building. But now with that spec-driven development, we need to be more specific. So what that means is we have an intent. My intent is I want to deploy something in Azure as complete as possible. Stepping away from that vibe coding, quickly build me a bicep template, because maybe now we have company requirements where we need to create like a multi-bicep approach, which means that we're going to create a modular setup. Instead of everything in one single bicep file, we need one bicep main file, and then underneath the different modules, right? We might have specific region requirements, maybe data compliance requirements, and so on and so on. So instead of immediately jumping in, which we could call the implement, implement phase here, we need to go through a few different cycles. A lot of explanations here. I'll share the deck, or I guess, Costa, you can share the deck at some point, or just maybe pause the recording, go back. I'm not going to read out everything here, but other things apart from like integrating bicep or just having my Azure infra ready is, for example, bringing in security, bring in compliance, one of the examples I already shared. Maybe adding specific requirements from the team, from the business, maybe from the region you're working in. And that means in vibe coding, you still have to go back and forth. Like, okay, first attempt of bicep works fine, but now I want you to fine tune. Maybe you want to run validation, like, is this template actually working? Not just from a syntax perspective, but also running the actual deployment and validation and fixing bugs. So that's where I hope this sort of, it's not really a decision, but it's more like a transition phase, I would say, where if you're still new to generative AI, new to Copilot or Cloud Code or any of the other AI tools, I think using vibe coding is brilliant. You have this idea in mind, you're going to use a prompt or multiple prompts, and it's going to give you what you need, and then gradually switching to a more spec-driven approach where you got all the different phases. Now, to get there, there is actually a platform where, no surprise, I'm going to talk a little bit more about how this works on a GitHub side. But if you again look at Cloud Code and other AI coding platforms like Cursor and again so many other, you might find that the concept is available across all those platforms. Now, what is GitHub SpecIt? GitHub SpecIt allows you to create that repeatable scaffold, if you want, where you're going to define artifacts. You create the AI engine, starting point, creates the artifacts, allows you to do the reviewing, connecting to it, and then mainly helping with what I describe as standardizing 4 different aspects of that overall spec-driven scenario. You build the artifacts, you got the planning structure, you got execution hooks and evidence capture, which is like the verify, show me that it's actually going to work. If you think about typical problems in, again, whatever development scenario you have, it's typically start me building something, but I have no idea what we actually need to deliver. You could say like a unclear scope, maybe bad planning. We got this idea, this is what we need to have, and it's going to take X amount of time. But oops, too bad, other priorities, we don't have the bandwidth, it's middle of summer, and maybe half of the team is on holidays, but we still have this deadline. And then obviously we start having like execution issues and not meeting that release time where we need to or postpone it. And the funny thing is that, again, since I've been working with DevOps for so long, a lot of the traditional DevOps concepts, maybe even if you look into Agile or any other, like a Scrum DevOps methodology, it's basically the same thing. So it's not like, oh, GitHub SpecIt is not at all important. I think it's brilliant. I think it's able to do really cool things, specifically for non-developers. And that's where I'll shift to another demo in a minute. But it's really about absorbing, understanding that concept. So you could say that this SpecKit approach and GitHub SpecIt, as an example, is becoming that backbone that's really keeping our traditional way of working, adding some AI sauce into it, and then aligning, bringing those teams together, but then also bringing in standards out of your platform. This is like one slide that's literally copied from the docs. So in short, this is the SpecIt, GitHub SpecIt lifecycle or the workflow, right? So it starts with constitution, interesting name. So what is a constitution? It defines what we describe as non-negotiable engineering platform principles, governance, security, language versions, like we standardize on Bicep, but always the latest version. Or you should always try and use like the Azure verified modules instead of just coming up with something it grabs from some large language model information. From there, you're going to move to the spec. The spec is where you define requirements, acceptance criteria, and they become explicit. From there, you're going to move to the planning phase. And that's where the tasks are getting translated into that executable work. In our scenario later on, literally creating Bicep templates or Terraform, and then maybe add sample code. Also make sure that like all the security aspects are covered, making sure that it's modular and whatnot. And then implementation, it's where you're going to run the actual deployment, and then validation, where you could think about the good old linter, just validating syntax. But now you could actually guide it into run this deployment into a test environment. From there, move it into staging and eventually moving it into production. Oh, and by the way, the only way to deploy our Azure infra is using a pipeline, which means you cannot use Azure command line. You cannot use I don't know, Azure developers, CLI, it always needs to be a pipeline. Oh, and by the way, it should be a GitHub Actions pipeline instead of like Azure DevOps. Or maybe we have this hybrid DevOps team, and some part of the business is using ADO, some part of the business is using GitHub, which means we always need two versions of the pipeline. So that's really that brainstorming phase, if you want, that I talked about before. Now, the nice thing is, so you need to install SpecKit, and I'll show you in a quick demo how you could do that. It requires Python, but it's only for the install. So that's a little bit weird, where you could install Python, like the latest version 13 point something, I think. And then once SpecKit is deployed, like one line of command, and you could remove Python if you don't want it on your machine. From there, you're going to run the specify command out of your, again, AI tool, like in my case, VS Code with GitHub Copilot, and it's going to create this scaffolding file. So you got the constitution. From there, you got the specs subfolder in which you're going to define specific features. And then you have the spec file, you got the feature file, the plan file, the task file, and so many other. Looks a little bit weird here. And again, I don't like reading from slides, but I hope in my demo that it's going to become more clear. One specific example that I wanted to highlight, that was obviously the topic of the session, how to use this spec-driven scenario, moving from vibe coding approach, quickly running some prompts, moving into this more mature, I think would be a good way to describe it, a more solid, more proven, more complete, more professional, more production ready. Like, so many things are better, but don't say that vibe coding is wrong. And then using that exact same approach, but not for developing applications. Because in the end, a developer writes code. But as a cloud admin today, you also start writing more code. And that's really, I would say, that bridge from development mindset into I can use this for pretty much anything. So the example I have is using Azure infrastructure as code. I'm going to use a prompt that I have copied somewhere on the site, where I'm going to use landing zones and then applying it to like a hub and spoke network topology. But it's just an example. You could use it for pretty much anything. So we're going to start with the constitution. We're going to write the spec files, and it's actually the tool itself that's going to write the spec files. And then from there, it's going to bring in some planning tasks, which means write me my actual bicep infrastructure as code, but then also adding, for example, tagging, RBAC boundaries. Maybe you got some, again, secrets, although in the network scenario, maybe not that specific, but that's what you write down in your constitution. And then implement validate is where you're going to require, for example, pipelines. Like the example I shared, we cannot run CLI for deployments. We need to use a pipeline. And then maybe integrating traditional bicep what if command lines, but you don't have to worry about it that much anymore. And the nice thing also with this spec-driven deployment or development is that a lot of those, oh, shoot, I forgot about this, or, oh, it's working, but now I need to go back. It's already covered. So that's, in short, the scenario I have. Again, I'll share the slides later on. So in short, we're going to wait for the constitution, the non-negotiables, right? Next to that, we're going to add specific spec and planning, where, again, I'm going to use that hub spoke topology using landing zones and then maybe some other components. And then eventually step 3 is the actual tasks. Write me my bicep files as modular as possible. Write me my ADO and GitHub pipeline YAML files, and then maybe run the deployment, although I'm not sure if we're actually going to have time for all of that. But that's the scenario. So let me show you how to get started. And I got my backup plan if something should not run as it should be, but I got some intention to try and run everything live as well. So the starting point for anyone is this little comment. So what it means is UV is just software install like a package management tool, where you ask to install a tool called specify CLI. That's the I don't know, tooling name for GitHub SpecKit, and it needs to download it from that GitHub repo. I would say maybe spend a little bit of time before like just going out as Peter's doing, like just run install and we're done. Because again, you need Python. If you don't have it, you need to install it. And then maybe if you don't want to keep it, you can remove Python, but you still need to keep your SpecKit, obviously. And then there's a couple of options on the latest version. I grabbed this one like 30 minutes ago, and it's the latest 14.2. And I think it's getting updated every couple of weeks. So after you run this in your terminal on any possible platform, Windows, Linux, Mac, doesn't matter, it's going to add all the different packages, and we're basically done. And then from there, you move into a new directory. This is my backup plan. And from there, we're going to use specify init command. Interesting. So I'm going to open a new terminal. And I'm going to do the GitHub spec live demo. And then here I got a couple of options. I could run like specify init. So that means call that specify CLI that we installed earlier. And then it's going to create a new SpecKit folder for me. I could open up VS Code and run it from there. So technically doing about the same. I was always a bit confused with specify because since we're talking about GitHub SpecKit, I think like SpecKit init would be a little bit easier, but that's details, right? So specify init, like initialize, we're going to give it a name, spec live. And then from here, if I don't specify anything, it should ask me which of these AI clients or AI coding clients do you have? This list is growing every couple of weeks. There's a whole bunch of tools that I never heard of and sort of recognizes like, I think you're going to use Copilot. Obviously, it doesn't really know. It's because I'm using GitHub SpecKit and it's assuming that I'm using GitHub Copilot for it. But if you have any of the other tools, then just know that the whole concept is basically the same. So I'm going to accept Copilot. And then from there, it asks me what kind of script language do you use? I'm going to stay with PowerShell because that's the default on Windows. It's also the language I'm most familiar with. But if you want, you could use Shell on like a Linux Mac or using Python. But that assumes you're already a developer, which I'm not. That's it. That's everything you have to do. Specify init, and from there, selecting your AI engine, and it's going to create this scaffolding for you. Now I can open up my VS Code. Building, or it already built, right, that scaffolding scenario. Now, what that means is that the technology behind it is nothing more than Markdown. So I'm just going to open up as much as possible here, so you got some idea what's in there. I'm not going to walk you through everything, but in the end, it's Markdown. So when I talked about the different stages, creating the constitution, creating the plan file, the specify file, the task file, that's all defined here. Now, this is not the file that you would use. This is the file that the SpecKit on its own is actually using. With a lot of details, but in the end, it's just plain English. This is giving instructions to GitHub Copilot, to the agent mode behind the scenes on how to integrate the concept of that spec-driven development into actual execution. Then from here, applying the actual SpecKit is opening up chat, where you're going to run /SpecKit. And that's, again, to me, a little bit confusing because we had specify on the terminal to install it. We had specify to actually create this scaffolding, but then calling the actual spec kit to start working on something like write me code that requires spec kit. So from here, you can do /spec kit, where you're going to use that prompting, maybe that bit of vibe coding scenario, and you're going to provide a description, like what you want. And let's see if I remember my sample prompt. And given some time constraints, I'll probably kick this off and then I'll switch to my backup plan where it has everything already up and running, but still got some time. So, oh, by the way, if we have any questions, I think we can take questions as well. So maybe you can post them, maybe you can interrupt me if there's anything specific you want me to ask. Or maybe, Konstantinos, you could help me and call out the questions when you see them popping up. I forgot to mention that. Help me building a full infrastructure as code for Azure deployments. We are standardized on bicep, and deployment can only be done using ADO and GitHub pipelines. The specific scenario is deploying an Azure landing zone with hub spoke networking topology across 3 regions. Pipeline deployments should cover 3 stages: test, dev, and production. You could say that here, this is, again, that natural language approach, just prompting, maybe that vibe coding concept. But now the big difference is that it's going to use that spec kit definition, the framework, the scaffolding, like following all the different steps that I explained on the slides to build up my core requirement. Where now the core requirement is it needs to create bicep and it needs to create YAML pipelines. That's really the simplification of this. Since it's using AI, human in the loop, we also need to define what kind of permissions am I allowed to use, or at least the agent allowed to use. Now you can play with this a little bit. So in here, I'm going to allow it for this session. If you don't like those recurring pop-ups, right, then you could move to always allow this. And then at some point, you could also switch to like default permissions, maybe testing with auto permissions, which is something new in preview, where it's going to ask you less prompts to confirm or less confirmations. I would say be a little bit careful with bypassing those permissions. I always like to read through what it's actually asking for to validate that it's not trying to do anything that it's not allowed to do. But at the same time, it's kind of convenient. Like if you do GitHub Copilot CLI, about the same, but instead of VS Code, you're going to run it in a terminal. You can do YOLO mode, and then it's basically like sending it off, and it's going to run and fix and validate everything on its own. Pretty cool, but that's where you see on like typically social media, like, oh my God, my AI engine wiped my C drive, or like the OpenAI issue. I'm pretty sure a lot of you heard about that. All of a sudden, somewhere last week, OpenAI agents and AI tooling started creating like a cyber attack, which that's the part that scares me. So right now it's still doing the same as before, where it's connecting to my MCP servers just because I have them and it's hard-coded in my VS Code to do that. And then eventually it's going to jump into the spec kit scenario. So I'll give it like an additional minute. And if it takes too long, then I'll switch to my actual completed scenario. I see a question here on screen. What's more important in the long run when building my AI skills is it vibe coding or prompt engineering? Well, I think there's like two different, that's again that blurry world that I talked about from the start. So in short, the prompt engineering is the concept, the guidelines, the best practice on how you interact with the AI engine using natural language. Now, there's a whole definition. I'm pretty sure there's maybe books written about prompt engineering, but that's just how to interact with the tool. Vibe coding means that you're going to use prompt engineering. You're going to ask a question. You're going to fire off a request. And if you pick up the prompt engineering techniques, which means you need to have a goal in mind. You need to have an intent. You need to be as specific as for Foundry. That's already a prompt. Moving from there to vibe coding means that you're going to be more explicit, more specific about what you want. Build me a bicep template for Foundry, including Cosmos DB, Hub, and Spoke, but I also want you to document it. I also want you to use Azure verified modules, and again, being a lot more specific. So I would start with really feeling comfortable with prompt engineering, finding out like what works as a prompt, what doesn't work. You can integrate different kinds of prompt scenarios, right? And then from there, using that experience into vibe coding. And then at the same time, I would say maybe targeted from a spec kit approach, because you have that full complete scaffolding as well. Now you can see here it starts running a lot of different things, and eventually it's going to build up everything. Now, for the sake of time, let me bring in my completed project. That gives me this. So what I asked for, I can show you the exact same thing. So I ran spec-it, loading everything in, asking a few questions, and then eventually starting to create everything that I needed. The outcome is my demo one folder. That's like my spec-it location. Same level as what I showed you in my live project, right? So we have our GitHub agents, constitution clarified checklist, everything from that specify in it. So basically the full definition files, if you want, the skeleton files. And then underneath, it's creating a new specs folder and allocating my hub and spoke landing zone, which was about the same prompt that I used earlier. Within, it's going to create the full scaffolding. So it starts with the constitution, the non-negotiables, and then it's creating markdown files for each and every step in the cycle. If I move to my constitution, or at least the outcomes of it, and I'll make it a little bit more readable. So you'd start with the planning phase. So what is the plan? I'll do it like this. So what is the plan? We need a deployment of that hub and spoke landing zone. It's going to analyze everything. And again, this is just the outcome of running that spec kit approach out of like chat/spec kit, providing the description of what you want. And it's going to build everything for you. Since I specified using the Azure verified modules, that's part of my constitution, like the non-negotiables. Oh, my other session is asking for something. Sure, you can do that. Resource inventory, so it creates my different resource groups. I asked for different regions, so that's where different resource groups are coming from. Creating my virtual network security groups, firewall, bastion, public IPs, internal IPs. There's the monitoring section, like everything is in here. In Constitution, we have that modular approach where it's going to add all the different individual modules, parameter files, and then I also specified create me pipeline files for ADO, Azure DevOps, and for GitHub across 3 different environments. And then it's adding some additional information like identity, credentials. Like you could specify we don't want like secrets anymore. We only rely on managed identities. We only allow X amount of ports communication out of the firewall. And that goes back to that brainstorming, thinking about all the requirements that you have and not just jumping in like a bit what vibe coding stands for. There's so much in here, right? So we have the planning phase, then inside the specs, it's almost doing the same thing, but now it defines the topology across the different environments, how to run the deployments, and then also explaining like what are the different goals. Now you could think like, why is all this necessary? Is this like an overkill of documentation? Well, in the end, I would say not really, because this is what the SpecKit agent behind the scenes is actually using to build up the full topology. Same with if you want to write .NET code, React code, Python code, anything else from that development perspective. And again, if you think about the traditional approach, you're probably going to start deploying something in Azure. To do that, we need CLI skills. To do that, we need Bicep or Terraform. We're going to deploy it. We're going to test it. It's live. It moves to production. And then maybe at some point at the end, we're going to write documentation. But we also know that the documentation is typically not something that we're going to update. Nobody likes updating documentation. At least I never did when I was still on the consulting side. It's maybe running a bit after the facts. And that's where now you could actually, oh, that's another thing, like how do you get started? Well, maybe you already have wikis. Maybe you already have a SharePoint site with all your project documentation. Maybe you have your repos with existing README information. That's what you can bring in thanks to that AI capability that's basically driving the whole thing. Where you could start like, well, I'm going to rely on SpecKit, but to build up my constitution, I want you to bring in information from my docs, my wikis, and whatnot. Similar to what I did with my MCP servers, to again make your final setup as complete as possible. So that's the scenario. Then it's going to move to the tasks. So the task list is again the next agent in the process, triggering all the different steps. And then inside, it's kind of funny because it's actually telling itself, this is the command you have to use to run this task. Now, the nice thing is that whenever something goes wrong, you could basically go in, you could call SpecKit, and then you would provide the actual tasks. So that's another option. If you want to revise your constitution, you could use prompting, or why not, since again, it's all markdown, you could basically rewrite your own files. So here it's task 1, author me the Azure module for observability, the hub network, the spoke network, the governance piece. From there, glue everything together, right? That's the composition. Next, run local validation, where it's going to run bicep lint, bicep build. So again, it's not doing anything different than what you as a cloud admin and Azure admin have been doing for maybe a few months, maybe the last couple of years. And it's now moving all that into step-by-step instructions. Natural language markdown, that's mainly what it's about. I see another question here, and I guess we're a little bit into Q&A time anyhow. Do we need to start learning a language at all? I can see we must be devs of some kind, but what's the starting point? Well, the starting point is natural language, plain English. And that's the thing, right? With like SpecKit, again, it's that spec-driven development. But in the end, nothing blocks you from just opening your GitHub Copilot or any other AI tool for that matter. And if you have your GitHub Copilot paid plan, you have agent mode, and you can just start using AI to create AI. And it's going to create markdown files. But then we're back in this sort of vibe coding mindset where you might miss certain characteristics. Depending on the large language model, it might be better or it might be worse. And that's where that whole spec-driven concept, and then thanks to the GitHub Spec Kit as the framework, is going to help you. But there's like no development involved whatsoever. Now, obviously, let's say, and it's a bit off topic, but let's say you want to learn Python, you want to learn .NET. One of the cool things, again, is that you can now start from an idea, and you could just ask Copilot, like, help me building this application. And if you don't specify anything, it's or going to pick up some defaults where I find out that if I just ask, like in my previous role as a trainer for building my demo apps and my web applications and like Docker sample containers, if I did not specify any development language, it would always default for Python. And that's where now in that spec kit concept, you would define like always use .NET, always use .NET 10 or 11 whenever it comes out. But I think the nice thing about this concept, and again, it's also why I wanted to talk about this 100% development-oriented scenario. As a concept, spec-driven development is targeting developers, no questions there. But then reusing the same concepts for non-development scenarios, like Azure Infra, I think was the easiest scenario I could come up with, to show that it's a developer concept that we're now reapplying to non-development tasks. I'll finish up. I think I got 2-3 minutes. So we had our spec kit skeleton with all the defaults, all the details in here, looping through a bunch of questions. So that's all for the clarification. And then obviously, I can imagine for the ones who are the actual cloud admins, you'll probably go like, okay, show me the templates, right? So it came back with a main template file. Syntax-wise, there's no error messages, so I think that's all cool. It's using the Azure verified modules. It follows the Microsoft Azure best practices regarding naming conventions. Monitoring is part of the setup. Governance is part of the setup. And literally, I started this like 30 minutes before going live. I had a other demo. If this would not work within 30 minutes before going live, I still had my other scenario, but everything is in there. And then inside, I have my Azure DevOps pipeline where it's using the multi-stage approach that I asked for, validating syntax, that's just linting, a little bit further, run my deployment towards a dev environment, and then eventually test environment, and then eventually production environment. If I want to do this for GitHub Actions, interesting, there's apparently a little bug in there where it's going to do the same thing, verifying bicep using linting, building a what-if approach. It doesn't like the Azure login. No idea why, because this looks actually, maybe it's an older version. I think there's a new version of that one. But everything's there in, again, just like 15, 20 minutes, starting from a prompt, using the spec kit, going through all the different steps in the scaffolding, step-by-step process, building basically everything that you ask for. So with that, I'm going to wrap it up from here. So what are the outcomes? First of all, you got that full scaffolding. You got that spec-driven development as a concept, as a mindset. You can, I guess, detect failures faster because it's already part of that process. If you ask for the or you define constitution, you move to plan, you move to test, you move to validate, like all those cycles are part of the process. Where again, it's coming from that development world where nobody likes to deploy an app that's not running. Nobody likes to deploy an app that has known vulnerabilities. Like all those dev/DevOps concepts are now basically moved into write me code, whatever that means, right, nowadays, and it's going to validate all those steps for you. And then it could help. That's the other thing. Like, why should I care about this as a non developer? Well, first of all, because it's allowing you to use AI, explore AI, use a bit of that vibe coding concept, but then also moving it into a more production ready mindset where it's not just like write me a prompt or use a prompt to write me some code, but eventually doing a lot more. So that's the main message I would say here. Message is simple. It's discover, explore, use that vibe coding concept, but then also use that spec approach for the actual delivery, more production ready, more solid, validated, verified. That's really it. So if you want to start with this, I would say, first of all, if you have any additional questions, I can hang around for a little bit more. You can ping me on email petender@microsoft.com. Find me on LinkedIn. You can reach me whenever you want. More than happy to help you out. If you go to GitHub within the next 30 minutes, I'm going to upload my sample repo that I used for the live demo into my GitHub environment, and my GitHub alias is petender as well. So you'll probably see it popping up there. And with that, I'm going to close out. I don't see any other questions popping up anymore. So with that, I'm going to thank you for participating. Thank you for being here. I hope you learned something as a non-developer, how amazing GitHub Spec Kit can help you becoming even better cloud admins, writing better templates, doing better validation, which means your Azure environment should run more solid as well. And Konstantinos, thank you so much for having me, and enjoy the rest of the sessions. Thank you so much.
Thank you so much, Peter. It was a pleasure as always having you. I learned something, of course, and I'm going to explore the spec kit. I didn't know that it existed. It looks like a natural evolution, and I hope it gets better. Thank you.
Pretty cool.
Thank you for being with us and presenting this amazing session today.
Thank
Have a
you.
great one, Peter.
You
See
too.
you
Take
soon.
care. Talk to you soon.
Take care.
Bye-bye.
Yes, with that being said, Peter presented really an amazing session. I didn't expect such a deep, um, theme to be here in us today. Personally, I learned a lot, and I can't wait to try the spec kit. As you understood, it will help you save a lot on tokens. It will help you define better uh, the specs of your deployment and drive your AI to do what is exactly you need it to do. Of course, if you are just starting and you're into this transitioning phase from being a systems admin, a cloud admin, and so on, or an administrator, I mean, it's obvious that we need to start developing. I have been into this path for the last 2 years. It's not easy, but it's a lot of fun. It's a lot of excitement, and it feels quite natural. If you start, you will understand that this is the logical path that anyone being into the cloud business or someone that would really like to evolve into the information technology profession and skilling, this is the way to go. So I believe this tool, it may be into the very early stages of development. I hope it gets better. I had a quick look into the repo. There are things that can be better, and there are things that look a little bit more difficult, I can say, but definitely worth exploring. And anything that comes towards us from the AI perspective, it will definitely help us become better, save money, and develop healthier and more defined, better defined solutions. So many thanks to Peter. He's always here for us, supporting our channel. So I hope if you're watching this either live or the recorded one. I hope you subscribe and support us. We're gonna have more sessions today, so let's have a quick break. And yeah, we're going to continue. We have a question here. Let me bring the question up. Any further tips for a desktop engineer who is looking to move to a cloud engineer role? Yeah, a lot of tips. So putting the AI aside and speaking from the system and the hardcore engineering lens in place, what I would suggest is learn infrastructure as code, learn what it means it means to have bicep on your hands or terraform. Those two are the best leading frameworks for deploying infrastructure through code. I believe this is one of the most important things that I was able to learn and understand. And from transitioning from a desktop engineer to a cloud engineer is focus into one of the big cloud vendors. Don't try to conquer them all at once. Focus on Azure, focus on AWS, focus on Google Cloud or Oracle, and of course try to understand the concepts of containers, containerization, Docker, container apps. I won't say Kubernetes. Okay, try to understand the concept, but don't try to be, the Kubernetes engineer. It's a labyrinth and it's very, very complex. So if you go through the route of infrastructure as code and focus in one cloud provider, you will get very early into the game and you will be able to understand better. And of course, certifications. Be active on the certification game. Try to get one, two fundamental certifications, the very basics one, and then move to the associate and expert levels. It doesn't mean that a certification makes you an expert, but it does mean that you get to understand the concepts. You are getting into the understanding of the vendor because the certification is more vendor aligned. So we have AWS certifications, we have Azure certifications, we have Google certifications. Choose from the quite big amount of certification. Choose one, two, three, and then you will find yourself in 6 months being already into a place to understand better. In 1 year, with consistent reading, experimenting, and not being afraid to try new things, you will see that you are now a cloud engineer. And then you can move forward to being an architect, unless you prefer to stay on the engineering game, which then provides you another challenge. Are you going to stay as an engineer or you're going to transition to the architect role and then to the senior architect and then to the principal architect? Or you're going to keep the engineering role at your head, meaning that you need to extend your knowledge. Then it comes wider knowledge of the cloud providers, better understanding of Kubernetes, and vendor agnostic certifications like the Kubernetes certifications. It's up to you. For me personally, I choose the first path, transitioning from a desktop engineer or a systems engineer to the cloud engineer and then to the architect. Um, I always like building solutions. That is definitely something that I won't stop doing, but I really like now designing the solutions and seeing this thing coming alive end to end. So you have a request, you design the thing, you bring the correct tools in place, you follow the well architected framework and the cloud adoption framework guidelines, and then you build it. So it's really nice for me to see this thing coming alive from the request up to the final build. Thank you for the question. So uh, let's take a small break, and then we will be right back with let me validate our next uh, session. Give me a moment, please. So, Freestyle Summer Jam 2026 by Azure Innovators Hub. I'm Konstantinos. I'm your host for today. We had already Michael Heath with us, and now we had Peter the Tender. We're going to have Konstantinos Lianos in a pre-recorded session. Then we have Jalil Muibi with another pre-recorded session, and then we have live Ready Gotham with the live session. The one from Konstantinos is building Microsoft Sentinel codeless connectors faster with an AI-assisted CCF skill. Very interesting, security-oriented. And Jalil is governed infrastructure operations, the pattern behind hybrid ops. So we have a hybrid scenario in our hands. And the last session, which will be live, is building resilient software through a continuous quality loop in DevOps pipeline. So DevOps is always welcome, and we really like to see DevOps sessions, especially live, because you see the thing happening, really in our screen. Let's have a quick break, as I said, and we will be right back with Konstantino's session. It's going to be pre-recorded. Thank you, everyone. We'll be right back with you. So let me bring up a media asset here. So yeah, here we are again, Azure Innovators Hub Freestyle Summer Jam 2026. I hope, guys, whether you are watching this stream live or the recorded one in YouTube, I hope you really support our channel by simply subscribing. That's all that I'm asking for. And you can follow me on LinkedIn, and of course, find out my blog and other community initiatives that I'm leading, like Global AI Athens chapter, a more AI focused community. Also, here in Greece, we maintain the Greek MVPs community, which is really going to take things a little bit more serious regarding more community events and also more physical events here in Greece. We had a very successful Global Azure Greece a couple of months ago, and the team is looking to take the game one level, more levels up. So yeah, let's hear Konstantinos Lianos with his session. Uh, Again, the session is building Microsoft Sentinel codeless connectors faster with an AI-assisted CCF skill. Let's see what this session is about. This is a pre-recorded session, but if you have questions, feel free to add them to our chat, and I believe Konstantinos will be around to answer them. Uh, let's play the session.
Hello, everyone, and thank you for having me at the Freestyle Summer Jam. My name is Konstantinos Lianos, and I'm cloud security specialist, and most of my work is one specific thing, getting security data from other platforms into Microsoft Sentinel. If you have ever built a data connector, you know there are two versions of the job. There is an easy version that show you in the docs, just configure the integration. And the other is the real version where you spend 3 days trying to understand why a validator rejects your file with an error message that tells you nothing. This talk is about closing the gap between those two versions. I will show you how I use a codeless connector framework known as CCF instead of heavy logic apps and function apps. And I will also show you how I put everything I learned the hard way into an AI shield. So every new connector starts from my old mistakes instead of repeating them. By the end, you will know when CCF is the right tool, where it will hurt you, and how to build your own knowledge base back so your team stops learning the same lessons again and again. I'll apologize. I jumped one slide. So quickly, my background is so you know where all this come from. I am a cloud security specialist on a DevOps team. My daily job is building Microsoft data connectors that runs in production. I do this with two hats. Some connectors I build for the community. Under my GitHub name, Kanena CS, Kanena from computer science comes the CS, and other ships as my Microsoft Partner Solutions, different name on the box, some work behind it. Outside of the code, I am also a regional leader in the Microsoft Global Community Initiative, the MGCI, and a senior Microsoft Student Ambassador. So sharing what I learn, like I'm doing right now, is a really part of what I do. Here's the important part. Every connector I build goes as a pull request in a public Azure Sentinel repository on GitHub. Real CI checks, real human reviewers. So when I tell you later that one missing quote characters fails a validator, I didn't read that somewhere. That was my PR. I lost that round. And the goal behind all of this is simple. Whether possible, replace the heavy stuff, logic and function apps with CCF. So the problem is getting data into Sentinel sounds simple. In practice, it hurts, and it hurts in 3 ways. First, heavy infrastructure. The classic answer to be we need logs from platform, let's say Informatica, let's say Azure Foundry, or let's say I don't know, let's say Platform X, isn't a function app or a logic app. Think about what that really means. You now own compute. You host it, you scale it, you watch it, you patch it, you pay for it. And what does it do? It calls an API and reshapes some JSON. That's all. We built a whole application to do something that's basic configuration. Second, The hidden learning curve, CCF removes the compute. Great, but the documentation is thin, and the ways it fails it is the worst way possible. Silence. You deploy the connector, everything looks green, connected, and then no data, nothing arrives, no error, no log, nothing. You just stare at an empty table, wondering which of the 40 settings is wrong. And third, the slow feedback loop. Many of these mistakes only show up in the CI pipeline of the Azure Sentinel repo. So the cycle becomes package, push the PR with the CI, read a strange error, fix one character, push again, one character, one full round. Make 5 small mistakes and make you pay 5 rounds. Each of these alone is annoying. All three together, that's why connector work feels so much harder than it should be. Let me continue. So, what is CCF? CCF is a codeless connector framework. Is Microsoft's way to build Sentinel connectors without writing code. The key word is declarative. Let me explain what that means in practice. You don't write the code that fetches the data. You describe the API, and the platform fetches the data for you. A CCF connector is really just 3 files, and all of them are configuration. One, the connector definition, where the APIs, how to log in, how to read page after page, the pagination, this is it, and what the screen in the portal looks like. Two, a DCR transformation, a small piece of TQL that saves the incoming data into your table. And three, a parser, a clean function on top of the table for the analysts. All of this gets packaged into one called a solution, a V3 solution. The format Content Hub use. So your connector instance like any Microsoft connector. The customer opens Content Hub, clicks installs, type their API keys, done. There are 2 ways to get the data in. And please remember these two, because they drive the biggest decision you will make. REST API pollers, pulls, it's called API on a schedule, CCF push, still in preview, receives. The source sends the events to you. So pull or push, keep in mind. And in both cases, there is zero compute of yours anywhere. Nothing to host, nothing to wake up at 3 p.m. or a.m. in the morning. So before and after, here's the trade in one picture. On the left, live with a function app or logic app. You own code, so you own its bugs. You own a host, deploy it, scale it, watch it. You own the plumbing, secrets, identity, networking. You pay even when nothing is running. And when it breaks at night, guess whose name is on the alert. On the right, the same integration as a CCF connector. Only configuration. No code at all. It runs inside the platform, so there is nothing to host. You set up authentications and ANS. There is no idle cost. You only pay for the data you bring in, which you are paying anyway. And polling retries, scaling, that's the platform job, not yours. In one sentence, CCF turns an operations problem into a configuration problem. That sounds like a pure win. and mostly it is. But a configuration problem with 40 settings and silent failures, that has its own price. That's we go next. Push or pull, the first decision. Before you write one line of the configuration, answer one question. Does the source push the data to you, or do you pull it from them? Answer it right, and everything after is easy in some way. Answer it wrong, and you will fight the framework for days. So the left side, the source has an API, you can call it, an events endpoint, a node log, something you can ask with time range. That's the CI, that's REST API polar. But three warnings, all learned the hard way. One, it can only pull. It cannot receive a webhook. Full stop. Two, it has no AWS style authentication, no SIG-v4, no assume role. If your source is in an AWS service, the Polar cannot sign the request. Three, your pagination settings must match what the API really returns. If you configure link header paging, but the API puts the next page link inside the body, nothing fails. You just silently get page one forever. So you must read very well and understand the documentation from the vendor. Right side, the source can only send events, webhooks, streaming. Then you have two options. Option one, CCF push, which receives the events directly. It works, but it's in preview. I'll show you what that means in real life later. Option two, what I call push to pull bridge. You put a small landing zone in the front. For example, in my AWS config connector, that's a Lambda writing to DynamoDB with a API gateway in front, and then the Polar pulls from the bridge on the schedule. Yes, the bridge brings back a little infrastructure, but it's a tiny dump landing zone, not a full application, and the Sentinel side stays completely codeless. So similar rule, if you can call the API, pull it. If the source only sends, push, or build a bridge, decide the first always. But even with the right architecture, the real time killer is somewhere else. Let me show what I mean. Is that this slide is the heart of the dog. Everything you see here is real, and every line cost me one share round. Look at the first page. Last update with the plain data fails. The exact same date inside update quotes passes. Why? Because YAML reads a plain data as a data object, as a data object. Apologize. And the validator wants a string. To a human, the file looks perfect. The difference between fail and pass is two quotes, characters, and the error message tells you nothing about that. Second pair, publisher ID, capital Kanenas rejected, small k accepted. That's the whole bug, one letter. And here's the thing, none of this is hard as you know it. Each one is trivial. The problem is the shape of the knowledge. It's a long list of small, strange, bold documented rules. TQL functions that are not allowed inside transforms. Packaging rules about when you must build. How logos must be referenced. solution IDs where wrong casing creates a flood of errors. That point is a wrong direction. The framework is not hard. Remembering 20 of these rules between one connector and the next, that is hard. This knowledge lives only in people's heads, and things that live only in your head leak out between project 1 and project 2. So at some point I asked myself, what if it didn't have to live all my head all? Um, and here's is the idea. Stop relearning the same lessons. Write them down into an AI skill. What I do mean by a skill, modern AI coding assistants can be given a knowledge pack. A set of documents the assistant reads before it writes anything. Rules, good examples, no known mistakes. Without it, the assistant writes a connector that looks right, and the looks right is exactly the problem because it looks right fails CI. With the skill, the assistant has already made all of my mistakes and it doesn't repeat them. The goal change completely. It's not to fix it by the fifth CI run anymore. It's right the first time. So what is inside in the skill? 4 kinds of content. Each one is there for a reason. 1. Good examples. Links to real working connectors in the public repo. Oracle Cloud Infrastructure for the overall portal shape. Sentinel Warp for the parser file. AWS config for the multi-connector connection screen. This is the biggest quality win of all. When the assistant starts from a working example instead of inventing one, the result stops being probably right and starts being right by construction. I do the same myself, even without AI. Before I fix anything, I open the working examples and compare. 2. A symptom to cause list. Every failure I ever hit gets gets an entry. What I saw, what the real cause was, and the exact fix. This matters because CCF errors lies to you. For example, a flood of SQL errors in CI is usually not a SQL problem at all. It's a solution ID with wrong casing somewhere upstream. If you case the symptom, you lose a day. If the list maps symptom to cause, you fix it in minutes. 3. Hard rules. The things that are simply not allowed. Written as never. Never use collags inside the transform. Never use capital letters in a published ID. Always quote dates in YARN, and so on. 4. The workflow itself. How to rebuild the package with a creation solution PowerShell script, and how to run the same checks, CI runs, ARMS, TK, and the YAML validator on your own machine before you push anything. If you think about it, this is just a lab notebook, but written written so a machine can read it. The AI brings the speed, the notebook brings the correctness. So 5 steps, the build loop, 5 steps, and the other matters more than any single step. Step 1, describe. Step 1, describe. I give the assistant the source. Here's the API. Here's how you log in. Here's the sample of the data. Step 2, choose a pattern. This is push or pull decision from before. Happen automatically poller or push, which auth type, which paging style. Choose by comparing with their working examples, not just it. Step 3, generate all the files at once. Connector definition, transform, parser, packaging, because they came from one description. They agree with each other. No mismatch between the transform and the table, which is a classic bug when you edit by hand. Step 4, validate on my machine. I run the checks and the YAML validator locally. The same check CI will run. Anything CI will catch, I catch now, in seconds, not in review round. Step 5, fix the open PR. Whatever the checks find, I fix using the symptom to cause list. And only this does the PR go up. So the key line is at the bottom of the slide. Steps 3 to 5 loop fast on my machine. CI stops being my debugging. It becomes what it should always have been, the final check. That change is where the word faster in the titles come from. Six traps, about 40 seconds each. 6 traps that keep coming back. Each one is now a rule in the skill. YAM dates, you saw this one. Dates must be inside quotes. Mild trick to debug it. Run the same YAM parser the validator use locally with a one-line node command. Then you see exactly what the validator sees. Publisher ID, small letters, always. And the hidden one under it, don't publish under Microsoft owns Azure Sentinel namespace. If you do, content have much solution with all deprecate Microsoft entries, and customers see the wrong thing. Use your own publisher ID. KQL inside transforms. The transform language looks like KQL, but it's a small version of it. Kolesk not supported. Packall not supported. You write them with nested leaf, checks, and plain pack. It looks like KQL, and that's exactly what it bites you. Zero ingestion, my favorite silent failure. You add start time and 10 time window filters because it feels clean. But if the API returns nothing for recent windows, you ingest nothing forever with zero errors. Remove those filters unless the API really needs them. Pagination, same story as before. Link header configured, but the API puts the link in the body. Page one forever. Match the config to what the API really does. That's why I say read it from the documentation of the vendor. Logos and IDs. The logo must point to a file in the repo logos folder, and not the pasted as a code. And the wrong chasing in a solution ID creates hundreds of errors that look unrelated. It's the most misleading CI output in the whole pipeline. Every one of these cost me at least one round. Now each one is a one line in a file. Real connectors. 6 connectors, one repeatable recipe, top row, ship it and working. Bitside, with data, it used to run on a function now it's a poller, and one connector can handle several Bitside accounts at once. Nice detail about the login. Bitsides wants basic auth with the token as username and an empty password. And CCF refuse an empty password. The fix is use API key of instant and build the basic header yourself with a small base 64 expression. Obvious after you know it, invisible on the docs. Oracle Cloud Logs, also move it off Function App. Now a version at 3.1 OCI taught me a money lesson. Keep the credential fields of headers, cookies, keys out of the transform. You don't want secrets in your analytics table, and you definitely don't want to pay ingestion costs for them. Also, don't store the same data 3 times in 3 saves unless you like explain a cost increase to your boss. Amazon Web Services config. This is the bridge from slides 6 running in the production. CCF cannot bulk AWS auth, so Lambda it on DynamoDB API gateway in front, and the Polar pulls the bridge. The sentence slide stakeholders. Bottom row, some work in progress. Mimecast UCCF push, the preview mode. I think it's in a peer review right now. The current task is to prove the whole path works. Send the test event to the endpoint and collect the proof for the reviewer, a screenshot of the connected state, the logs, and the query showing the data landed. That's why preview means in real life. In real life, the reviewers want proof, and they are right to ask. Juniper missed, send another push to pull or build. Skeleton done, waiting for the live testing, and the friends has the template ready and is waiting for the API access. A good reminder that sometimes the slow part is not the engineering, it's the paperwork. So the results, four numbers and the honors with you. These are my numbers from my own work and not a formal benchmark. 6 connectors built with one repeatable type, and everyone made the next one faster because every lesson went into the steals. 2 kinds of heavy infrastructure going away, logic apps and function apps, 0 servers of my own in any of the shipped connectors. And first, because the target is now right the first time. And CI has a very slow, very public budget. The real story is the computing. Normally, experience fades. Right into a steal, experience adds up. Okay, these are takeaways. So, one DCF deserves a change. Forgetting API data in Sentinel. Try CCF before you build a function or a logic app. 2 is the cost, is the hidden knowledge. You can learn the framework in a day. The 20 silent traps are what cost you weeks. 3, write the knowledge into an AI skill. Good examples, a single to cause list, hard rules. Turn pain into something reusable. And this is the recipe only for CCF. Any tool where your team keeps knowledge in their hands is a candidate. 4, check before you push. Run the CI checks on your machines. Compare with a working example before you fixed. Learn CI confirm, not discover. Huh, okay. So that's the talk. Everything I show you is public. The connector lives in the Azure Sentinel repository, and you'll find my work under Canon ACS on GitHub. Thank you very much. And I don't know. We have time for questions. And if anyone wants to go deeper with the one connector, the BitSide login trick, the AWS bridge, the Memcached push, find me after that the session as well. Thank you very much, everyone.
That was Constantino's session. Really interesting. I always like security sessions, you know. Let's have a quick break, and I will bring up our next speaker, which is also um, a pre-recorded session before we move on to our live last session. Thank you, everyone.
Hello everyone, I hope you're having a good summer.
Okay, so our next session is coming from Jalil Muibi. We're going to hear about governed infrastructure operations, the pattern behind hybrid ops. Jalil is the first time that he is submitting to our group. We're very excited to hear what he has to present to us. Unfortunately, the session is pre-recorded. Not quite unfortunately, but we prefer live ones, as you know. So whether you are watching live or you are watching the recorded event on YouTube or LinkedIn, please subscribe to our group. That's the only way that we can get any support from you. And I'm really thankful that you're here supporting us and supporting our speakers. Jalil Muibi, Governed Infrastructure Operations, the pattern behind hybrid ops for now.
Hello everyone, I hope you're having a good summer and thank you for joining me on this section. I'm Jalil Muibi and I work across hybrid infrastructure, platform engineering and infrastructure automation in general. Without wasting much time on introduction, I'd like to start this session off with this question. And the question goes as, a pipeline can finish green, everything ran, but was it the right change against the right state with the right authority, and can the team recover when an assumption is wrong? This talk draws on current research and operational guidance, introduces 4 records that make an operation reviewable from request through recovery, and test the pattern through hybrid ops, the public hybrid infrastructure platform I created. By the end, you should be able to examine one of your own workflows and identify where intent, authority, decisions, and evidence still live only in pipeline history, a long script, or somebody's memory. Picture the situation at 2 a.m. in the morning. The automation runs and every step exceeds successfully. The infrastructure is there. Later, the team discovers that the request used a stale inventory, changed the wrong environment, restored from the wrong recovery point, or left traffic pointing at the old service. The pipeline was green, everyone was happy, but 4 questions were still open. Was this the change we intended? Did it use the state the organization actually trusts? Was the action permitted at that point in the life cycle? And is the resulting service usable, recoverable, and in a known operating position? I am not arguing against pipelines. Repeatable execution is essential. The point is that execution success is narrower than operational success. A process can be perfectly repeatable and still be incomplete as an operating model. The gap usually appears at the boundaries between the request and its target, between declared state and the live state, between automation and authority, and between a successful change and a controlled return. Those boundaries are where I want to spend our time in this section. Adoption is high, value is conditional. Platform engineering is no longer a fringe concern. DORA reports that 90% of organizations use an internal developer platform, and 76% have a dedicated platform team. It also reports that developer independence, meaning the ability to complete lifecycle tasks without relying on an enabling team, is associated with 5% improvement in productivity at both team and individual levels. Those figures support self-service. They do not support self-service without controls. The same DORA guidance warns that poorly managed platforms can reduce throughput and change stability. We can remove one coordination delay and replace it with ambiguous choices, weak feedback, or unsafe convenience. So by standard, I would not measure a platform by its catalog size or merely by the presence of a portal, pipeline, or platform team. I would look at a complete user journey. Can somebody request an outcome, understand the plan, receive a meaningful refusal, verify the results, and recover without having to reconstruct the process from implementation detail? Adoption is high, but whether a platform is genuinely useful still comes down to how it's designed and operated. Guidance, coverage, and boundaries. If we strip away the product names, the same pattern appears in Microsoft Azure well-documented guidance on self-deployment and business continuity. Before a change, the guidance recommends quality gate and pre-deployment checks. During the change, it asks us to access workload health instead of trusting the execution process alone. If a problem appears, the operation should stop and the vine recovery path should begin. The business continuity guidance makes the boundary wider still. Recovery is just not a provider feature. People are involved. So are manual and automated procedures, failover, failback, risk decisions, and regular review. That means automation is part of the system being operated. It has its own inputs, authority, permissions, dependencies, failover mode, and residual states. It also means a platform has to expose more than a button that starts a job. A user needs to see what was resolved, why the operation may proceed, what a healthy result looks like, and what will happen if that result is not healthy. The terminology changes from one source to another, but the direction is consistent. Intent, decision, execution, verification, and recovery need a relationship that somebody can inspect. Now I'm going to talk about the 4 operational records. I use 4 records to make that relationship visible. First, there is the declaration. It describes the capability being requested, its dependencies, the input it needs, and the checks that define the usable results. Next comes the resolved plan. It shows which environment policy, target, and implementation will satisfy that declaration. A stable request becomes a specific operation. The third record captures decision and else gates. Can this operation proceed? Afterwards, is the result actually usable? Permission and else are different facts, but both belongs with the operation. Finally, the runtime record connects the original request to the selected implementation. The transition that ran, the results that was observed, and any state or action left behind. When I say 4 records, I do not mean 4 new databases or 4 new products. A product might be a version specification, a resolved plan, a signed approval, or a structured run results. What matters is that we can inspect the links between them. That gives specialist implementation room to change without changing the meaning of the requested capability or losing the account of what happened. This next slide is about a recovery case. A model earns its keep in a difficult operation, so let us test this one against a recorded PostgreSQL recovery drill. The normal service position was an on-premise high availability cluster. In the drill, a 3-node recovery environment was restored into GCP. That environment produced a fresh recovery side backup, and the service was then returned to a rebuilt on-premises cluster. The cloud restore took 26 minutes and 58 seconds. The fresh backup took 27 seconds. The controlled return took 9 minutes and 38 seconds. These are observations from non-production drill. They are not a production recovery time objective, an enterprise benchmark, or a claim about scale. The timing is not the most important part. The workflow also had to keep 3 things coherent. Number 1, authority. Which service location was allowed to write? Number 2, continuity. Which named recovery point crossed each boundary? And number 3, closure. Whether the service route returned, data protection was restored, and the remaining cloud state was known. Successful steps alone do not connect those facts. The 4 records give them a controlled lifecycle. The first record, declaration. Look more closely at the first record. The starting question is not which command should run. It is, what are we declaring? The public specification on screen accesses the on-premises PostgreSQL source. It names the capability, the operating mode, the authoritative inventory and database state references, and the outputs that downstream work may consume. Something important is missing by design. The operator is not writing a provider command sequence. The request is a source assessment with specific state relationship and named output. That leaves room for the implementation to evolve without changing what the next stage is entitled to expect. It also removes some ambiguity. Source export ready means that the process exited 0. It is a named operational fact from specific assessment. Source replication candidate is another fact that the managed recovery part can use. Naming a fact does not make it true. The implementation and checks still have to establish it. The contract gives the workflow a stable language for its dependencies and outcome. So this is the first boundary. Describe the capability before binding it to the mechanism that will perform the work. Record number 2, which is the resolution. The declaration is stable, but something still has to turn it into an executable operation. That is the job of the resolved plan. The intent contract supplies the capability, inputs, and required outputs. Environment policy adds target-specific defaults, authority rules, credentials, and state binding. A versioned implementation then performs the work against a named target, with the resulting state kept inside that environment boundary. This does not hide the implementation. Operators still need to inspect and troubleshoot it. The aim is to prevent the implementation from becoming the only place where the operation has any meaning. Policy may differ between shared foundation and disposable development environments. A target may move from an on-premise estate to a cloud recovery position. The implementation may also change with the underlying system. However, the capability, its dependencies, and the checks that make its results trustworthy should remain stable. Before anything changes, the resolved plan makes the binding visible. Which policy was selected? Which targets? Which implementation? Raw execution often leaves those answers implicit. The plan puts them in front of the operator. Record number 3, the refuser. Here, the correct outcome can be no change at all. This pre-flight shows why a valid request is not automatically an authorized operation. The blueprint validates and resolves into 5 ordered steps. Pre-flight then checks those steps against the named environment. The network foundation is protected shared state. This request targets a development environment, so policy refuses it before any external change. The dependent steps are deferred rather than run against the partial foundation. That distinction gives us 3 very different kinds of failure. An invalid declaration cannot be understood. A policy refuser means the request is valid but not allowed in this context. An execution failure means an authorized operation started but did not finish as expected. They may all stop a run, but they do not mean the same thing. Each calls for a different response. One red status wastes troubleshooting time and may encourage people to walk around the protection they do not understand. A useful refuser names the boundary, explains why it was reached, and leaves a safe next action. Here, the useful result is a valid request being understood, checked against the policy, and stopped before an unsafe change is made. Now I'm going to talk about authority and observation. We also need to separate declared state from observed state. Automation blends the two, which is not ideal. Declared state tells us what should exist and who owns that intent. Observed condition tells us what exists now and whether it appears healthy. We need to compare them, but we should not confuse them. Suppose a provider reports an unexpected network, root or service endpoint. That observation should not become the new desired state. Either remediate the environment back to the declaration or deliberately approve an update. In a hybrid environment, no single control plane sees every layer. An inventory system may own allocation and topology intent. A provider API reports resource condition. A workload probe tells us whether the service is usable. The operating model keeps those roles clear. Observation informs a decision. It does not gain authority simply because it is live. Now I'm going to talk about decision modes. Working automation is not the same as authority, so how should the platform decide? Not every operation needs human approval, but not every operation should run automatically. I use 3 decision modes. An automatic operation runs inside declared limits. A governed operation may resolve a plan and collect readiness information, but wait for an explicit decision. A blocked operation cannot proceed because the required condition or policy is not satisfied. In the recovery case, restore confirm is false by default. The system can access the source, resolve the plan, and show what would change. What it cannot do is grant itself permission to restore a database or move service authority. Approval belongs to that specific operation. Starting a pipeline does not imply it. Risk and context determine the right mode. Routine reconciliation may be automatic. Promotion, destructive restoration, or traffic cutover may need a governed decision. Missing source state should stop either one of them. Recovery itself is a life cycle, and this is what I'm going to talk about in this slide. Now, follow the record through the full round trip. The source estate is accessed first. The workflow identifies the active service position, checks whether an export is ready, and names the source that the next stage is allowed to consume. It then selects a specific recovery position, not an informal idea of the latest backup. The cloud environment is prepared and the database is restored. But resource creation is not enough. The cluster must form, data continuity must be checked, and the service route must point to the recovered position. The recovery environment is now the active service position, not just the target. The authority boundary has moved with it. Before the return begins, the active recovery primary creates a fresh backup. The return path rebuilds on on-premises targets from that position, reestablishes the high availability topology, verifies the service, and only then move routes back. This is why I describe recovery as a life cycle, not a restore command. Source assessment, recovery point selection, writer authority, infrastructure, restoration, health, routing, failback, and residual states are connected, but they are not one transition. In one opaque job, a green result cannot tell us which state crossed each boundary or whether the path back still works. Now, on to record number 4, which is the runtime evidence. A screenshot can look convincing and still be incomplete. Taken after the controlled return, this one shows a leader, 2 streaming replicas, and no replication lag. This tells us something useful. It is not the full operational record. It is a snapshot, and a snapshot needs context. The runtime record connects the chosen source and the recovery position to the decision that allowed that transition. It links the operation to workload health, the service route, remaining states, and the next available action. Without those links, the screenshot proves only that one command displayed a healthy looking result at one moment. It cannot tell us which backup was used, whether traffic returned, or whether recovery resources are still running. The operation should produce this record as it runs, not rely on somebody assembling the story after an incident. An environment scoped record leaves less history to reconstruct under pressure. Now, I'm going to talk about failback under the context of failback not being a cleanup. Recovery stories often end too early. The service has failed back, so the job appears to be done. But state changed while recovery was active, which means the return part needs its own contract. The backup used for failover is now historical. Once the cloud recovery position accepts new rights, returning from that old backup would throw away valid work. The return operation pins a fresh position from the active recovery primary. It rebuilds the normal environment, restores the state, reestablishes protection, and moves the route only after the workload is healthy. The control on the left keeps restoration disabled until the correct backup reference and decisions are present. What remains? Should cloud recovery capacity stay for investigation, be stopped, or be removed? Have routes, record, and credentials returned to their normal position? Is the continuing cost visible? Those are the questions that need to be answered while the process is going on, because these are operating decisions. They are not footnotes after a successful restore. The same applies beyond databases. Rollback, failback, tear down and decommissioning all change authority and states, sometimes with more risk than the forward deployment. A workflow is complete when it can leave a service in a known position after success, refusal, interruption, or return. Now, let's talk about what the case establishes. We need to be precise about what this case establishes. We saw a required pre-flight failure stop an unsafe external change. We saw one declared operating relationship continue across failover and failback. And we saw how a request, decision, transition, and observed result can remain connected. Public specification and run records make those statements inspectable. This was one controlled drill, not a universal recovery benchmark or a claim of enterprise-scale performance. The model complements provider native controls, it does not replace them. Those limits are useful. They tell us what was tested and what would need a different evaluation. What can transfer is the operating boundary, a stable declaration, visible resolution, explicit gate, and a runtime record covering the reverse path and residual states. Measure outcomes. If catalog size is not the score, what should we measure? Start with complete workflow. DORA recommend measures including lead time, deployment frequency, failed deployment recovery time, change failure percentage, and deployment rework rate. Alongside those measures, Ask about the path the user actually took. Did they complete the task? Did unsafe work stop before external change? Was the refusal clear? Did the operation verify workload health or just resource existence? Could another operator see the current state and the next safe action? Under the stated conditions, how long did recovery take? These answers tells us more than catalog size or execution count. A platform can add capabilities while making important workflow harder to reason about. A smaller platform creates value if one journey becomes safer, faster, and easier to hand over. Measure the whole path, including how it fails and how it recovers. On to the big question. How do you start? The answer is simple. Start with one risky workflow. You can try this without redesigning your entire platform. Start with a workflow where a mistake would matter. Allocating a network, promoting a replica, changing an identity boundary, removing an environment, or restoring a service. Write the declaration. What outcome is intended? Which state is authoritative? What does the workflow depend on? And which checks divide success? Then make resolution visible. Before execution begins, show the policy, target, and implementation selected for that request. Introduce one required failure. Remove a credential, supply stale upstream state, or target a protected environment. Check that dependent work stops and the refuser explains why. Now, verify the workload independently from resource creation. A virtual machine can exist while its service is unreachable. A database can run while the root still points somewhere else. Record what remains and what next. The operator should know what finished, what remains, and whether to resume, recover, or remove. Finally, ask a second operator to rehearse the return path using only the declaration and record. If they need the author's memory, the workflow is not yet an operating model. The next useful improvement may not be another portal, it may be a clearer contract, a meaningful state, or a better record around an existing workflow. And that brings us to the last slide. Returning to Hopeling question. Under pressure, where does intent live? What outcome was requested? Which state has authority? What must be true before execution? Who can decide? What implementation makes the change? And what proves the results and the path back? Repeatable execution remains essential. Governance makes it understandable, controlled, and recoverable under pressure. If an answer exists only in pipeline history, a long script, or one-person memory, begin there. I used IBDops as a case study today. The link on the screen lets you inspect the implementation, explore the scenarios, and challenge the model. Thank you for spending this time with me. Enjoy the rest of the summer jam, and I look forward to the discussion.
Very nice, very well presented by Jalil. I'm really thankful for the recorded session coming into our Freestyle Summer Jam 2026. It's the middle of the summer here in Greece. We're hitting temperatures like 35. The other day went up to 40. Mm, some days we are lucky enough to get 30s and 31s, but yeah, we are around 33 on most of the time. At night, it comes a little bit lower, so you don't need the air conditioning to be running all the day, all the time. Freestyle Summer Jam 2026 by Azure Innovators Hub. Thank you everyone for joining. Whether you are watching our sessions live or you are watching the pre-recorded, the recorded event from YouTube, uh, spread the word. Send our link of our channel to your IT professionals, IT enthusiast friends. We have really interesting sessions from this event, as well as previous events and standalone sessions, mostly around Azure, AI, integration, development, Microsoft 365, DevOps, and everything that's around the next generation of applications in cloud. The honest, let's say, or the transparent description of my channel is the following: is my journey from becoming a system networking voice over IP enthusiast, uh, transitioning to cloud integration, AI, modern development, and now architecting and solutioning around Azure, Microsoft Foundry, and the whole Microsoft stack and the Microsoft ecosystem. So it's really interesting to have a look into the channel and understand how the evolution came. Of course, you won't find systemic videos because the channel came up at the point in time where I was deeply into Azure, but you will find and see actually how one can evolve and start, working their way up or working their way towards uh, specific technologies and really nice stuff that Microsoft brings into the table and into the era that we're living into. So while we're going to wait for our next speaker, allow me to explain what we're going to have. Uh, we're going to have Ready Gotham with building resilient software through a continuous quality loop in DevOps pipelines. I hope that Ready will be able to join as soon as possible. In the meantime, let's have a small break. Let's grab a cold or hot drink or simply water from wherever you are. Thank you, and hold on for our last session for the day. So, thank you again for being here with us. Freestyle Summer Jam 2026 with Azure Innovators Hub in the middle of the summer. An event that came as an idea for people to be able to deliver sessions out of their own ideas, nothing with strings attached. something that I had this idea a long time ago, but I couldn't find the right time frame to position it. And in the middle of the summer, our brain needs to be restful, needs to be not worried, and needs to be very cool and smooth. And of course, we are in the I'm sorry, the northern hemisphere, where of course summer is hot right now. And since I'm located in Greece, Europe, you can understand. But from wherever you are connecting and you're joining, my sincere appreciation for supporting the channel. Please subscribe to this channel. There is also another one named Global AI Athens. It's part of the Global AI community, of course. You may have heard of it, but our small chapter is gaining traction, and we have also very interesting sessions coming there. And there is also the tech community group from the tech community Microsoft, the user group, modern development with Azure and AI integration. You can also be a member there. You can follow me on social media and you can connect with me. I'm really open to connections and people, um, that would like to have some assistance, some help, some mentoring, some coaching into their careers, into their solutions, or solve some high level problems, or take some hard decisions regarding cloud AI, especially on Azure and the Microsoft stack and ecosystem. I'm Konstantinos, and this is Freestyle Summer Jam 2026. We are waiting for Eddie. I have communicated with him, and he's almost ready to come and deliver a live session. A challenging, always a challenging aspect to deliver a live session. That's why I have great respect for everyone delivering in our events. Even the recorded sessions, that's almost something that you're doing live, but a live one has its own challenges because anything can go wrong, and it usually does. But people are very, flexible in finding solutions. So it's a joy to have a live session for watching things happening and delivering a pipeline, for example. And that's exactly what Red is going to show us. We have a session for building resilient software through a continuous quality loop in DevOps pipelines. So sit tight. We're going to be with you right now because I see Reddy just joined the room just before I started the video for the break, so we don't need a break. I'm going to bring Reddy into the screen and he's going to introduce himself. Let me bring him on. Hello, my friend. Hello, welcome. Welcome to our channel.
Hey, Kusantes, thanks for having me here. I'm really looking forward for this session.
Yes, we would like to thank you so much for being here with us at this point in time. I don't know, I think you're connecting from India or from somewhere else. Where's your
I am
location?
from San Francisco Bay
San
Area.
Francisco, yeah. That's very nice. It's very nice. Also, Peter called from San Francisco earlier, so that's really nice. So, what time is there? It's early in the morning, something like that.
It's actually I'm on PST, Pacific Standard Time. I am at 11:40.
11:40. Okay, okay,
Yes.
okay, okay. Again, thank you so much for coming with us and presenting the session. We are excited to hear what you have to say about building resilient software through a continuous quality loop in DevOps pipelines. So, my friend, the stage is yours, and we're here for you. Thank you for joining.
Yeah, thank you, Kusantes. I mean, give me 1 minute. I mean, I my session was a little bit later, so I didn't upload the slides. Now I
No
see the slides.
problem.
I think we're all good. Let me see. Can you guys see my slides?
Yes, of course.
Okay. Okay. Great. Thanks for having me here. And this is Jyotishwara Reddy Gautam. I am currently work at Walmart Global Tech as a software quality engineer or SDET software developer in test. And I have 15 plus years of experience in quality and automation. And lately, last couple of years, almost into dabbing into AI and how to integrate AI into workflows. Today I'll be talking a little bit of old style topic, but how we are using AI, and maybe give a little bit of what we are doing and what I'm observing, what I'm learning. Let's get started. Obviously, the topic name is like building resilient software through continuous development loop in DevOps pipelines, right? This is more like a DevOps forum. I'll give you how we are in the shift left kind of approach each of areas, how we are integrating the quality instead of it is one of the specific areas to be once your development is done, you're coming to quality. It's not like that. How we are each phase of from the product owner evaluating the requirements till the your code in the production and observability and every single area, how we are integrating. That is kind of the topic that I'm going to discuss. This is a kind of agenda, or the topics that I'm going to very high level, why traditional quality model falls short on the age of AI era, and the continuous quality loop, and shift left and shift right engineering, and AI-assisted quality engineering, and automated quality gates, observability, and resilience engineering, and continuous feedback, and some challenges, success stories, and the best practices what I've been observing. So first thing is why traditional quality model falls short, right? See, quality was once a gate and head of the pipeline, in the sense when you think about a waterfall, even for that matter, Agile or even the rapid development, right? Quality always came after the development phase, and you used to have whatever the quality engineering checks, and they write the test cases and be ready. By the time it reaches the QA, developers are already moved on to some other project, or they're waiting for the bugs to show up. Even making the fix expensive and release unpredictable. If you think about if you find a lot of bugs in the latest stages, then developer has to redo the work, and your timelines, everything is at stake. So this is not going to work when you have in the AI. We went from once in a 6 month development to Agile, where we have a 2 weeks releases, and then we went to weekly releases. And I see in my team, in my own eyes, we are now 2 releases a week, and we are in discussion with how we'll have a daily releases. And in San Francisco Bay Area, when I talk with a lot of peers, some of them have already daily releases, and some of them having 2 releases a day as well. And at that pace, you can't have a quality as gate, separate gate. It need to be integrated in all stages of your development. And this is kind of your old way of doing things, like one pipeline, right? You are having a requirement gatherings, and then development, and then testing and deployment, and then operations, which is how we have done things in last decades and a couple of decades. But now it has to change. What is the consequence of this, right? You have the late defect detection, and your production surprises, and you have a slow release cycles, and you have a zero operational feedback. If somebody found in a bug in the production, you are fixing it, and it's not being integrated back into the development lifecycle. So modern complexity demands more. Basically, now you have the services, APIs, or GraphQL, whatever you're using. It's all microservices and APIs. It's no more monolithic one system, right? And your Kubernetes containers, your deployment cycles is ephemeral, and it's going on and on, and it need to be testable and stable, right? And the cloud and event-driven architecture, and even distributed databases. Now, continuous quality loop, the core concept is quality becomes a continuous process. That means it's not one phase. It's from the beginning of your requirement gathering to the planning, every development, and then when you're testing, and your deployment, and your operations in observability, every single stage you have a quality integrated into your pipeline. Now, how the loop works, the 5 core principles is continuous testing, which means you have your automated test run very early, like a shift left, and I have a shift right as well. And you have the continuous validation, the verify the correctness under real world production conditions. And you have continuous monitoring, real time visibility into systems health and user behavior. And you have a continuous learning, production incidents from the next and test strategy. And it's like a continuous improvement, right? Every cycle reduces the defect churn rate. And shift left is not like a very new concept. It's been here for last couple of years now. Like basically the test very early, so you are like fixing your bug cost fixing is very less compared to like if you do it later stages of the time. And obviously you do a lot of unit testing, even the functional testing at the stage. And you have the static code analysis, and you have API contact testing, even the security scannings and everything is done very early. It's not like a phased out later stages of the time. And obviously the second thing is a shift right validation. Basically you have a candidate deployments. Instead of deploying everything 100%, you go with like 1-2% and see if you find a production issues or something. And obviously you can pause at that time and fix it and roll out and learn the lessons and implement those things in the later stages of the time. And you have a synthetic monitoring and real user monitoring, and use the feature flags, do all this to make it like your validations or whatever you are doing for your testing, right? It may be automation, it may be manual, it may be semi-automation and semi-manual. Still, you can use the feature flags to make sure like it all goes well. And obviously the next thing is AI-assisted quality engineering. Nowadays, I mean, obviously every single thing we do has to be AI integrated into it. The one way we are doing is the test script generations and even the test case generation. Instead of you manually writing it, give it to the AI to let it generate. And obviously you have a human in the loop, but end of the day, it's generating the test cases for you and test scripts for you, so which you can integrate into your CI/CD pipelines. And doing the intelligent regression, instead of you're running like hundreds of thousands of tests in entire product line, now you have like your PR. You can look into your last 1 week or 2 weeks what PRs went live, and with that give it to the AI to analyze and see what is the vulnerable areas in your application. And later you can have like your regression run only specific to that particular area, so it becomes like a more intelligent regression. And the same thing you can do, give all your PRs like whatever is merged last couple of weeks, see what is the anomaly, and you can detect the anomalies, and you focus specifically in those areas. And obviously the failure prediction, surface hotspots and coverage gaps before code ships into the production. And obviously this is the main thing we are talking about, right? The automated quality gates in every single area, from the commit to build to static analysis to unit test, right? Typical grade criteria is like a code coverage, making sure it's more than 80%, no critical vulnerabilities, static analysis, performance baselines, and API tests, infrastructure validations. Every single place you have like your quality gates enforced. Now, obviously, cloud native observability. I'm sure, like some of you use Azure and maybe some other cloud platforms. But end of the day, like the monitoring is key part of the quality gates, right? Because you need to have like you have the matrix, you have the logs, you have the traces to make sure your matrix will give you different kinds of set of data, and logs will give you different sets of data, and traces will give you different set of data. But end of the day, you need to make sure like you need to identify the signal out of the noise. And that kind of like once you have that signals, you can integrate that into early development life cycles. And resilience engineering and chaos testing. Basically, chaos testing is like basically you are anticipating like what kind of like failures that can happen in the production, and you are in the lower environment. You need to make sure like you perform the same same kind of like whatever, like kill the container or block the network traffic or inject the artificial latency, restart the your Kubernetes cluster, or what to measure, basically recovery time, or error rate, user visible impact windows, and automatic self-healing success, and all these things, right? And there's a lot of tools in the market which you can use perform this resilience engineering and chaos testing. And this is like a continuous feedback, right? Closing the loop. Basically, you have the product alert, and you do the like root cause analysis and missing text identified and whatever the artifact that is, and you add the new automation test. So it's every single time when you keep doing that, the over a period of time you will have like your quality get more matured, and you will have like less and less production incidents, and less and less cost occurring for that. And enterprise results, I mean, this I see with my own eyes where I work, and also when I talk with the different forums outside. When you integrate this quality pipelines end to end, right, you have like a 60% faster defect detection and 45% fewer production incidents, and deployment confidence is going up. Biggest one is like when you're connecting production inside directly into developing through continuous feedback mechanism, not adding more tools but integrating existing ones into your unified loop. That's where you have like more success. Key takeaways and best practices to talk about, right? The one thing is the thinking has to shift from like it's not like one thing. Quality is a continuous like improvement, and you need to make sure it's not like a shift left or shift right. You need to make sure on both sides you're covering, so you kind of catch the defects on both areas, and use the AI to accelerate your quality at scale. Maybe the test script generation and signal prediction and analysis of like anomaly detection, whatever it is. Use in anywhere that where you can use AI to make your life better. And gates enforce standards without gatekeeping. You need to make sure like obviously it has to run automatically. It doesn't day one it's not going to happen, but your goal is to make sure sooner or later you will get to that area. And obviously observability plus resilience, right? Your operational maturity, understand why things fail and prove systems survive when they do. And future of DevOps is a continuous quality. Obviously early, you detect early, respond faster, improve continuously. That's what we are looking at end of the day. It's not just about delivering faster, it's about delivering with confidence every time. So you have like less production incidents, and you have like more uptime for your product. So that's pretty much it from my side. Thank you for your time, and if you have any questions, I can take it now.
That was quick, my friend. Thank you so much for joining. I hope you have a great time, and I really hope to see you again in a future session of Azure Innovators Hub. Thank you so much for being with us. Have a great one.
Thank you.
Take care.
Thank you.
Bye bye, my friend. Bye. Yeah, that was it. Quite a fast session from Reddy, as always interesting, because here in Azure Innovators Hub, we choose our sessions very carefully, and we hope you enjoyed today's event with our beloved speakers. 5 speakers for today, Freestyle Summer Jam 2026. Quite a relaxed, smooth attempt to provide to you knowledge, expertise, and probably some ideas for you to explore uh, in the months of July, August, and I don't know, probably for the end of the year, because we heard a lot of interesting things. At least me, I'm going to explore some of the topics that were presented today by our speakers. I would like to thank you, everyone, for being here with us. Either you're joining live or you're watching our event as a recorded event in YouTube. Subscribe, leave a message, connect with us. We would love to hear from you. And as always, we're looking for speakers. So be on the lookout for more call for speakers. Thank you, everyone. Have a great one and be safe. Bye bye.